I'm sharing your presentation.
It's titled Digital Transformation through a Real OEM Data Hub, Integrated Relevant Controllers and the Internet of Equipment. The floor is yours.
Yes. Kindly confirm if the PPTs are visible to you. Is the PPT visible?
Now it is loading. It is loading. Yeah. Now we can see. Yeah.
Now it is visible.
Yeah, it's visible.
Ma'am, can you make it in larger view? Yes. Now it's working fine.
Right. Over to you, Sanjay.
Will they able to see or
Sorry?
no? Then how they will able to see or
Yes, let me transfer it to center.
is it? I think
It is in your laptop.
yeah, it's on my
You
laptop.
can put your laptop there.
Oh, yes.
It's perfect. Yeah, go ahead. You can keep your laptop here so that everybody can see that.
Oh,
Go to the picture. Meanwhile, I'm getting it tonight.
oh, okay. Or I can wait for some time.
You have
We
five
just-
sketch.
No, I have code 35, so that's fine. I mean,
It is only.
But the thing is that if you change the slides, people won't see it. So
Yes, everybody will be able to see it.
no,
Yes.
I think let's see. Just
Let's wait if we can.
Ma'am, is your laptop is connected with the projector there?
Wait.
You need me to grab a spare?
Yes, because it was working, then again, this is disconnected.
It was, and it was just practice. So I think we need to see it and I'll be working from the yard, so.
Right, right.
Right, I'll let Chris know you need them. okay?
Sure.
just give us.
Sorry?
No, it's connecting.
Yeah, it is
Just give us
connecting.
two. I think it's fine.
No issues.
Okay. Oh yeah, it is.
It is visible, right? You can see that?
Yes.
Perfect. Over to you.
Oh, I'm sorry.
No problem.
Please,
Sure. Thank you. Do I need this?
yeah,
Hello. Will you hear me?
Yes.
It's okay.
Please adjust your laptop camera. Yes, please adjust your laptop camera on your face, please.
Okay.
fine, that's fine.
It's fine. That's okay.
Yeah,
Oh,
that's
it's okay?
fine now.
Yeah.
Yeah, that's fine now. Thank you.
Very good. I think I'll take this one. I'm sorry. Hello, very good morning, good evening, good afternoon, whichever part you are joining in this call. So this, I mean, I'm Prasoon here. I just give you my brief introduction. I'm currently working at Hardcore Rail. It's a railroad manufacturing company based out of South Carolina. And having total of 20 plus years of industry experience. So this is one of my very first, I would say, my third paper that I'm presenting because I've started shifting to the academics recently. I'm also pursuing MBA at the University of South Carolina. So it's kind of one of my, after 20 years of spending industry experience and all, I'm planning to venture myself into the academics now. So this is one of my paper that I have worked on. I have done the research, extensive research with an implementation strategy, and also let's dive into that. So this is one of the digital transformation through Rail OEM Data Hub, which is an integration between the telematic control unit, we can call as a TCU, with the Internet of Equipment. We will come into the Internet of Equipment, what I'm trying to mention about that. So this is my abstract on this. So that's the abstract of my particular paper. Yeah, you can briefly. Hello. Yes. What we could try to see is that railway equipment manufacturing companies like we work on a really large life cycle specific product. Means whatever the product that we build, which take around 30 to 35 years of lifespan of each and every machine. So what we saw that over the period of time is that to build a particular railway machine, we have a multiple applications, we have multiple systems. However, those systems are not connected to each other. Not only that, also we found that there are a lot of other customer data, kind of telematic information or any other IoT data and everything. Those are not interconnected to each other. So this is the paper about to connecting all the different multiple systems together into a data hub. We will come into other details eventually in this paper. So let me get into the first slide, which is just try to introduce with this paper. So as I was telling you, the railroad OEM manufacturers we have a very long service life. It means any product that we build, which actually takes around 30 to 35 years to build for the entire life cycle. So we wanted to have a multiple stakeholders environment. So what we saw over the period of time is that there was a customer expectation has been shifted. So the customer expectation has been shifted from the product delivery to the outcome-based contract availability. So what we saw that what we wanted to do is they wanted to be more performance benchmarking. They wanted to look for more sustainability commitments and the availability guarantees. So, however, those all systems are there, infrastructures and everything. But what we found that the OEMs has not kept in the pace because the data has been fragmented over the multiple system. So if you see in this below diagram, I try to highlight what are the different kind of systems that a railroad manufacturer can have to maintain. The first of all, the engineering systems, which is nothing but if you're aware of the PLM, CAD, which is the product lifecycle management, and the CAD applications and all, so those systems are basically to manage and maintain the data when we are going to build some new product. So that's the kind of inception of the particular product being built on the particular system. From that, of course, we have a manufacturing system. Means after you build this particular system or build the particular machine or build the particular product, you need to actually go into manufacture it. So you need a MES system, you need an ERP system for the planning and for the build records and everything. Of course, we have a service system. Service system comes into the picture. It means that when you deliver your machine to the customer base, how the end users or end customers are going to utilize your product. So that's come into the service system. So there are like like asset management system. There are CMMS, field inspection systems. So those are coming into the service systems. And the last one is the customer systems. What is customer systems? Customer systems are the telematic information which we try to connect it from when the machine is actually on the track. So how they can send the data, they can send the information back to the control room. So that's actually the telematic system. So these are the four major systems that we are currently working as per our current scope of the work. And let's see what are the gaps of each and every system that we found over the period of time. So let's identify so what we did was we first identified the research gaps of all the systems. So what we found that there is no unified asset identity system for this particular. So of course we have an existing lakehouse, IoT data mesh and everything. But the traceability between the PLM system, the EAM system, the MES system, and the telematic data all are kind of siloed. It is not been connected to each other.
Ma'am, please unmute yourself. You're on mute.
You're right. Who are not here, they do not know the challenges. They say. Are you able to see the PPTs?
Yes, ma'am.
Just a sec.
Yes, ma'am.
So that you should enable editing.
Yes.
But there is a button enable editing. So
No. I was trying to go with this full.
Yeah.
Enable it. Absolutely.
that's great.
Wonderful. This is your PPT, right?
Yeah, just F5.
Yeah.
I think they should see the full screen.
That is what I'm checking.
That's-
Are you able to see full screen now?
Yes, ma'am.
No, not full screen.
No, ma'am, not yet.
Then please put into the presentation mode.
Okay, no, this is good. Yes,
It is good.
that's good for us.
Which slide you got?
Yeah, no, I'll.
Thank you so much.
No problem.
Please go.
Yeah. So yeah, so I'll go ahead and for the next slide. So this is the main research objective for this particular paper. We
Sir,
wanted to
sorry,
define
sir,
the
sir.
rail OEM data hub with a reference
sorry to
architecture,
interrupt you,
which
sir.
we are integrating, which is the telematic control unit enabled IoE
Sir,
telematic.
your slide is not working, sir. Sorry to interrupt you. Your slide is hanged.
It's not moving.
Share.
You just unshare your slide and share again.
Does it, are you able to see now?
Stop share. Okay. Yeah.
Yeah.
So they
please
wanted
share
to
again.
unshare and reshare.
Yes. Share again and make it full screen.
Yeah.
Is it visible now?
No, yeah, it is.
Yes, ma'am.
Research objectives we can read.
Okay.
Now we are back to the original first slide.
So which one you guys are seeing? You're able to see the literature review?
No.
Then
I
what are you
think your
seeing?
slide is hang again.
It's okay. Please continue. You continue.
Yeah,
That
please
I'll manage.
continue. I think that's a
You
better.
please continue. Yes.
Yeah. So I was talking about on the research objective for this particular paper. As I said, the first objective was to go for the data hub of the rail OEM with the internet of equipments, and the second one was the temporal asset identity with the genealogical model. The third objective was for the so we took an empirical deployment for this particular strategy, and we have been collecting the data for 340 field assets over the 18 months and measuring the outcome across the reliability, maintenance, and the OTA compliance. And of course, in this paper, we are also going to look after the governance operating model, which is proposing the data product ownership and the accountability of the structures. Let's deep dive into the methodology that we worked on it. We of course started with the structure synthesis. What we did was we tried to decompose each and every domain. Like we have a multiple domain to look after, like starting from the engineering, manufacturing, services, suppliers, and the customer operations. And we did the decomposition of that particular domain. And then we started looking for the synthesis between those each structures. Then we did our empirical validation. We had an 18 months observation. We tested for the 340 field assets over 18 months. We collected 2.1 million of daily telemetric events, 1,400 and maintenance work ordered. We also look for the KPI measurement approach, which means the baseline. We established the baseline of the pre-deployment of PLM, EAM, and the MES system. we post-deployment metric captured for the 6-month, the 12-month intervals. We took a 90-day rolling average applied on the control seasonal variations. Then we went for the platform evaluation, and we took a lake house, of course, so we have streaming and the data ingestion. Okay. Yeah, sorry, my slides. Okay. So these are all the main methodology that we've been look after. The next slide, I'm going to talk about the we implemented or we kind of came up in this particular paper. So this is the very high level architecture that we created for our particular paper, particular research of this one. So in this particular architecture, if you can see, there are like 5 basic layers that we created. The first layer was the edge telematic control unit, which is nothing but the CAN FAT and J1939 protocol integration. We did the secure gateway and the OTA controller. We had a V2V, means vehicle to vehicle and vehicle to process communication. The second layer was the ingestion and the connectivity. We use the MQTT H2 cloud streaming telemetry for the data ingestion. We use the Apache Kafka for the event processing. We also use the data capture or the change data capture or the CDC for the system synchronization. We also had a layer of a lakehouse code, which is nothing but doing the storage and compute, which has a raw zone, standardized zone, curated domain zone, and the ML features. The next layer was for the semantic and the asset identity. We had the temporal asset genealogical graph across the PLM, MES, EAM, and the telematic. We had the central KPI standardization layer. We had the temporal configuration of the queries. So what this particular architecture is the main differentiator is there are the 5 main differentiator of this architecture. The number 1 was it is using the streaming, it using the batch, and is using the API integration. It also records the full lifecycle asset identity. It's an AI-driven closed-loop maintenance. It's centralized, secure OTA, and the data mesh governance. So what we did was, what happened, or what are the findings that we found after the 12 month of the empirical outcomes. So what we saw that it is actually reduced 31% of time to the root cause analysis. So previously, for any kind of problem, we had a root cause analysis done by the 4.2 days, which is reduced by the 2.9 days now. We also had an unplanned downtime of 23%, which is reduced from 9.1% to the 7%. We increased our OTA compliances by 28 points. We, of course, reduced our sustainability reporting by 94%. So what are the findings? And apart from that, there are major findings we had on the lot level traceability, on the predictive maintenance maturity. We also have a semantic standardization, which is one of the main problem item of our research when we started with, and we also had a governance dependencies for each and every phases of that particular work. Let's talk about some of the implications and we'll drive into the future directions. So what we did is there are like 3 to 4 3 main implications that we found. The implication 1 is for the practitioners. So what you have to do, you have to sequence the investment, you have to resolve the asset identity and the KPI definitions, and we have to, of course, look for the integrated security. For the OEM strategy, what we did was this particular strategy is actually going to enable the new revenue model so that you can ask for the predictive maintenance subscription, you can ask for the OTA license features. So this will be your new OEM strategies to get your revenue growth. And for the governance perspective, you have the data product ownership, you have the cross-domain operating procedures. So these are the main governance implication that you will get. For the future research, what you can do is, what we have is we need to focus on the more federated learning, the rail ontology standardization, and the V2V and V2P autonomy. So these are the major research areas that we need to focus on for the future. There are, of course, some limitations we found of this research. The main limitation we found that on the single deployment context, because of the generalizability to this OEM type, requires the further validations. We also had an 18-month window, which is not captured for the long life cycle mode for the heavy rail industry, because heavy rail industries are more than 30-35 years lifelong. So it's an 18-month window that we took for the empirical study may not be sufficient. So this is kind of one of the limitations that we found for this study, because we need to keep the machine running over the period of time, and then you can collect the data and get the more information. So I'll just quickly come back into the conclusion. So in this particular conclusion, what we found that our rail OEM data hub is TCU enabled, is edge intelligent with the lakehouse analysis. So what the lakehouse analytics is nothing but a combination of a data warehouse plus your analytics. So that's coming to the new technology as a lakehouse analytics. It also has an asset identity modeling. It has an OTA lifecycle. It has a governed data products. And what we did on this particular research is all this concept what I just told. It is not only just the technically feasible, but it is deployable. And we are currently operational on those technologies and everything. And we of course have a data running from 12 months to 18 months running from this similar architecture. So we found the root cause. Of course, we have the proven results. We got the results really positive, at least after the 12 months of the empirical study. And so this is kind of a dual blueprint. It is not only referencing the architecture, it's actually implemented into the organization and giving a positive outcome. So I will end up with this particular statement, which one of our president actually told after the deployment of this particular solution: competing on the sustained outcome, not merely a product delivery. It requires the integrating and digital thread from edge to enterprise. So this is the basic idea for our data hub for our Internet of Equipment system. Thank you.
Thank you very much for this study. And any questions from the audience? Questions? Any questions that would like to validate the bar?
Or you can stand and take questions.
Or any questions from my question?
Yeah. Fine. You can have them, so I can just read out the questions.
Okay.
Thank you, Prashant. So it was really interesting to see all the metrics out today. So a couple of questions from my side. So before the data hub, how was the same information being managed?
Yeah, thank you for the question. Before the data hub, I showed in one of the presentation. Can I change this?
Yes.
Just
Yes.
to show. So if you see this particular slide, so data was of course managed. It is not that because. So if you see this diagram, so data was managed in 4 different. So we have like multiple systems. We have engineering systems which manage the design data. We have a manufacturing system which designs the manufacturing data. We have a customer system. So all the systems were working in kind of items to each other. So what we try to do is we try to make it connected to each other so that we can have some better analytics. We can have our predictive maintenance. So predictive maintenance is very important. Let's say for example, you have a car, right? So in a car, whenever you go for the oil change, you go and say that okay, after 40,000 miles or 10,000 miles, you have to come and go for the oil change, right? So this oil change is kind of because we are working on the railroad OEM organization. So there are multiple aspects to check, not only from the like engine oil or those kind of things, because we have a lot of other aspects that we have hydraulic oil, we have electrical interconnects to check. So those checkpoints have a lifeline. So all these things were there in the service system, for example, but they doesn't have any interactivity with the engineering team or the engineers. So that's what we want to get connected.
So you mean the predictive maintenance is one of the most business value outcomes?
Yes, so that's an excellent point. Yes, so predictive this is one of our revenue builder. So it's kind of, previously it was always like we need to reach out to the end customer that okay, when you want to get this one. Now is that we already have the data in our hand. So we can reach out to them that okay, our data says that you are in. So in my paper also, if you go, I actually wrote those points. So we have a proper system around on that.
Nice. I mean, I have one general question. So it's basically about transferability.
Sure.
How well this architecture can be transferred to a heavy industrial equipment like mining or other things?
Oh, excellent point. So, yeah, excellent point. So, the industry that I'm coming from is a railroad equipment manufacturing company, but that actually comes into the heavy industry manufacturing company. So, it's just the very similar technology, very similar things. Only thing is that we build the machine and we got the rolling stock. Means the entire, huge machine that we're building is actually rolling to the track. So, the same technology can be implemented in any heavy machinery industry. May not be, good for any other industry, but for the heavy machinery industry, because whichever industry uses this kind of 4-5 systems, this particular architecture can be plugged in. So it will be kind of pluggable. On this and of course, there's a certain things we need to configure and all. It's not that because we didn't build this particular technology or to apply it. It's kind of very specific problem to resolve. So that problem may not be there on that particular previous stream.
Cool. Yeah, that's all I have. Thank you.
Thank you so much.
Thank you very much. I took, yes. Yes, you can put with me.
Oh, yeah, sure. What's your paper? Paper 3, right?
Thank you, Mr. Sawa.
Thank you.
The next presentation is Umar.
He will hear me, yeah?
No, it's your paper.
Guys, so
Oh,
my colleague.
Sure. Oh, yeah. So I will call upon the presenter, Ozan, so to present the integrated EV and hydrogen vehicle energy management paper. And here we go.
Thank you very much, my session co-chair.
The paper.
Yeah, that's it.
Untrue, right?
That's it.
That's one.
That's all. Let's enable everything.
Yeah.
Yes, everyone is ready.
Here you go.
Let's make it a bit small so people can see it.
If you can quickly confirm, are the slides visible?
Yes, ma'am.
Yes, ma'am, your slide is visible.
Right, you will be able to see the screen. Could you please confirm? If it moves, if it's full.
No, not in the full screen.
At least
You can continue.
Yes,
with
yes,
the
please continue.
normal.
Okay, yeah, let's go. Now, today the topic that I want to present is on integrated energy and cost management in electric vehicle and hydrogen vehicle purposes. Actually, it's the very beginning of a student of mine for her master thesis at the very beginning stage. We did more. I want to also express more on that. But first of all, what we're talking on. the transportation is responsible for a non-negligible part of overall global emissions, so that there are different actions that the governments or decision makers are taking, and in this manner, the electrification of transportation. What I mean about electrification is such a full body electric vehicles. It also includes whatever type of vehicle that's can be hydrogen powered vehicles, or it can be like rail systems or everything else. So here the number of electric vehicles is increasing, and the industry is paying attention for this, academy is paying attention for this. And when we come to the battery electric vehicles and fuel cell electric vehicles, the situation is that the battery electric vehicles has a good level of energy efficiency, while fuel cell electric vehicles powered by hydrogen has 2-3 times more primary energy per kilometer. So it means when you can go like 200 kilometers or 250 kilometers, you can go really over 500 kilometers by a hydrogen vehicle. So in this paper, my student actually provided a decision-making mechanism for a parking lot that's overall managed charging and refueling of electric solar battery electric vehicles and fuel cell electric vehicles in the same premise, and that's also supported by grids, surely grids, the external grid, and also distributed generation unit by photovoltaic systems and energy storage system. So here there's a co-optimization considering the cost on energy. Cost on energy management for an electric vehicle and hydrogen vehicle parking lot supported by PV, ESS, electrolyzer, and hydrogen storage system. Now, there are lots of literature studies, and there's just a small categorization on it. Electric vehicle smart grid integration is a topic that includes majority of the papers, and there are some papers on electric vehicle charging plus renewable energy supported and grid. What we mean as semi-grid charging, partial grid charging. And there's some papers on electric vehicles plus hydrogen systems that's coupled with hydrogen systems, but there are less papers on prior co-optimization of electric vehicle and hydrogen vehicles at the same premise and supported by PV, ESS, and multiple energy carriers. And here, the methodology includes system configuration of some numbers of like 20 electric vehicles, just to exemplify, now 15 hydrogen vehicles, rooftop, a roof carport type actually, 150 kilowatts of PV, an on-site inner storage unit, a small size of electrolyzer to produce hydrogen to support the hydrogen vehicles, and hydrogen storage systems. There's a case study with a real data from the parking lot in Istanbul, Turkey. Sorry? No, let's continue. And the objective is the cost minimization. That's operational cost minimization. The constraints, you can see all the equations in the paper, so that just I'm briefing it. The grid support limitations for electric vehicles, their charging power limits, state of energy dynamics, and arrival departure time bounds. For energy storage system, again, there is discharge limits and state of energy evolution, min-max bounds. And for the hydrogen system, the electrolyzer power replication and hydrogen vehicle refueling dynamics and hydrogen storage systems dynamics. And the solution is, the problem is modeled as a mixed integer linear programming model, and it's applied in GAMS, generic algebraic modeling systems. And the PU profiles gathered from Human's nature for the exact site, and the arrival times are simulated via Monte Carlo simulation. And these are some input data that use the electric vehicle brands that my student considered, and the hydrogen vehicle. Something's happening. And hydrogen vehicle brands that my student is again considering, and there are Monte Carlo based arrival and departure times on the left hand side for electric vehicles, And on the right-hand side, there are again Monte Carlo simulation-based arrival and departure times for the hydrogen vehicles. And on the left-hand side, you can see for electric vehicles and for the hydrogen vehicles, the initial, first of all, for electric vehicles, the initial state of energy that when they arrive, and the desired level that they want to depart. Like, okay, I arrive with 20% of charge, and I want to depart at least with 80%. That's it. That's targets. And state of hydrogen in terms of kilogram hours for hydrogen vehicles. And on the right hand side, you can see the period profile for this simulation day. And very briefly, the total operation cost, and surely all the vehicles gathered whatever energy or hydrogen target they want to have. For example, a very brief example for vehicle 9, when we call by numbers, it arrives at 11, departs at 17, 5 p.m. And active charging is between 3 p.m. and 4 p.m. The reason is that the cost is lower than compared to the other periods to charge together from the grid, and also with the PV support. And surely smart scheduling the first charging to low price high PV windows. And again, we can give all the vehicles for hydrogen vehicles, but just to exemplify the page limits. And for example, for hydrogen vehicle 5, for the refueling times, it arrives at 1 p.m. and departs at 4 p.m. And more active refueling is not between all these periods. More active refueling is between 2 p.m. and 3 p.m. And the reason is that the green hydrogen produced by electrolyzer during the peak periods before this period is utilized by storing in, first of all, in hydrogen storage unit and dispatched to the hydrogen vehicle on time due to its demand. And the PV and ESS support primarily energy. Grid purchases are limited to deficit periods where the cost is more lower, and or the PV and ESS cannot reach the goals, and excess PV is sold back. Just a small conclusion. I will tell more on what actually she is doing now. Apart from this paper, I will leave the floor for 3 minutes for this. And there was a mixed digital learning programming-based technical framework for a hybrid electric vehicle, hydrogen vehicle parking lot supported by PV, ESS, electrolyzer, and hydrogen storage unit. Key findings is the role of inner source systems where PV alone surely is insufficient, and you should face more grid constraint, more grid high cost grid periods so that your cost will be high, and smart scheduling by the decision-making mechanism defers EV charging and hydrogen vehicle refueling to low price and hard solar windows. And here the contribution apart from this for the ongoing work is that normally the thing is that there are multiple types of electric vehicle service stations that should be, because in all stations, for example, there are also some studies of placing electric vehicle charging, hydrogen vehicle refueling, and also battery swap options. I don't know if you're familiar with battery swap options. And a battery swap means that when you come there with the active battery or low energy battery, and in 2 minutes the machine swaps it with a full battery, so that there is a really scheduling need for this, and this schedule of all these options also can be used in some periods for grid support. On the other hand, removing the reverse flow, how? For example, if there's a resilience issue in the grid, like some sort of storms or other things, locally this place can act as a power producing part, like 1 hour, 2 hours, with the whole side batteries or other options. So there are lots of studies, lots of issues from the industry in different regions. Combine all these options in one, also with the capability of reverse power flow. So my student gave some future extensions also with the back to the grid option. And the back to the grid option, she already did it with as a normal journal paper. So it's an ongoing study and it will continue to be there. And thank you very much. Any questions?
Yeah, no, you can have it. So I have,
Maybe from the audience.
anybody from the audience having questions? Yeah, okay. I have two questions. So you mentioned three mechanisms: demand charge smoothing, energy arbitrage, and electrolyzer efficiency.
Yeah.
Where does the cost savings actually comes from? Is it from all three or any one of them?
Where is the cost from?
Cost savings.
The cost savings. The cost savings are coming from majorly, for example, for the photovoltaic power production, you cannot do anything. That's how it how the irradiation is. That's there. But the thing is that if you can provide like the cost savings that generally come from ESS because normally there is an input from PV and there is a demand from electric vehicle charging. Forget about hydrogen vehicles. There is a demand from electric vehicle charging. It means that the difference between them should be directly supported from the grid, regardless of what cost it has. But when you have an ESS, it's a buffer. You can store how much you want, and you can reuse it whenever you want, so that you can shift the periods of high cost to low cost periods.
Okay. Has this been implemented? In
That's the arbitrage, actually.
Yeah. Is this still a simulation study or it's being piloted in any actual site?
The thing is that for some sort of it, there's a in our campus there is a carport site, like including in our campus in Ilsequars, there is an installed 2 megawatts of photovoltaic power, and there is over like 80 kilowatts in one carport that's supported. That's all. That's supported by 8 vehicle charging stations of Siemens. And there we are now installing an ESS and we're trying to do it in a physical manner.
That's all. All good. Thank you.
Thank you very much. Anyone else for the first session? You'll be there. You have a very confident.
Oh, you're from the first session?
Because we are last in first session, it's the reason we are changing for presenters.
So what paper I will go? I'm 40. Who's that? So you're the first presenter?
Yeah.
Yeah. Welcome in.
You could be there.
Yeah. So, yeah, I think you can.
No, we can.
Oh, you have the slides there?
Yes. Yeah, sure.
You get it.
Yeah, you also have the first presentation.
Yeah.
When you are putting there.
Thanks. Hello everyone. So we are welcoming Saki, presenting this paper on lithium ion battery life cycle physics and energy. Here you go, sir.
Thank you.
That's
So this is my presentation. So should I save it somewhere?
Yeah.
Yeah, okay. Next.
This one is. Request you to confirm if the PPTs are visible.
Yes, ma'am, it is visible.
But it's not.
Slideshow.
Wait, we need to
Close the.
close this first. More important, it should be visible here. And then.
Yeah, exactly.
Is that right? Yes, good to go. Oh, yeah, yeah. Good. All best.
Thank you.
Yeah.
So, good morning, everyone. Today I'm here to present my work on lithium-ion battery life prediction using a physics-guided attention framework. So, as shown in this workflow, the proposed approach connects four main elements: the early cycle battery data, an attention model, a physics-informed degradation curve, and finally, we use that to predict the cycle life. The central idea is that instead of predicting battery life cycle directly as one black box number, we first predict the battery's degradation trajectory and then derive cycle life from that trajectory. So this distinction becomes important when we think about how batteries are used in real life applications. So some major battery application areas include electric vehicles, grid storage, and battery manufacturing. So here, accurate early life prediction of batteries in these applications improves the performance, reliability, and cost-effective decision making. So compared to the traditional testing, where a cell is typically cycled from cycle 1 to end of life cycle, which may require hundreds and thousands of tests. In contrast, the early prediction approach uses information from early stages of early life cycle, early cycles, like from cycle 1 to cycle 100, to estimate the full time behavior of the curve. So now the question arises, can we really learn from early cycle data to predict long-term battery aging? So to answer that, we first need to understand why the battery aging is difficult to model. So as is shown in this slide, battery degradation is challenging because it is not caused by one single process. On the left, we have internal degradation mechanisms such as lithium plating, loss of active material. On the right, we have external influencing conditions such as temperature, charge, discharge rates. These two sides interact, and the coupled effects of these, such as higher temperature, can accelerate chemical degradation, and manufacturing variation of these batteries can cause two different cells to age differently under different conditions. So battery aging becomes nonlinear and path dependent, where two cells may look similar during early cycling, but they might diverge substantially in the later life. This complexity creates a modeling challenge, and it explains why existing prediction approaches often involve some trade-offs. Here, the motivation is to address these trade-offs. The table here shows some of the trade-offs of these models, where data-driven models are flexible and accurate, but when enough data is only available. However, they are often black box models that may generalize poorly when applied to new battery batches or operating conditions. Second, we have the physics-based models, which are interpretable and are tied to degradation mechanisms, but they can be complex, require many parameters, and may be difficult to calibrate for practical use. So we bought in hybrid models, which can combine both data models and physics-based models. These are promising, but many still focus only on predicting single life cycle number rather than the entire degradation curve of the batteries. So what we're trying to do is we're trying to achieve this triangle on the right, which shows we have to balance the accuracy, we have to have interpretability, and also get generalization. So this brings us back to the main idea of the proposed framework. So on the left, we have the traditional framework, which is the direct cycle life prediction, where early cycle features are passed into a machine learning model, into a black box, and the output is simply the predicted life cycle. But in our case, our approach is that we use a trajectory first prediction. So here we have early cycle features which are passed on to a attention model, and then from the attention model we extract the required physically meaningful degradation parameters. These parameters are then passed into a physics informed model to basically reconstruct the entire degradation curve of the battery life cycle. Then using this entire degradation curve, we estimate the end of life threshold. So now, now that the framework is clear, the next question is that what data do we use to learn this relationship? So this is the data set used for this study. We use the well-known data set called Severson et al. Battery data set. Here the measured signals include voltage, discharge capacity, internal resistance, and also the temperature. So this table summarizes the data set, where the original data set splits into 84 cells for training, 24 cells for primary testing, and 18 cells for the secondary test set. Here, the secondary test set is especially important because it comes from a different manufacturing batch and uses different charging schedules. So therefore, it provides a stronger test for generalization. From these raw measurements, we need to extract early cycle features that are informative about long-term degradation. This slide shows the key equations. The key equation at the top defines delta Q 100 minus 10. It shows the discharge capacity curves at cycle 10 and cycle 100. At first glance, these curves may appear very close because the battery is still in its early life and yet doesn't have any significant capacity loss. However, when we subtract these two curves, we obtain the difference curve shown on the right. This difference curve makes subtle aging related changes much more visible. That is why we treat the delta Q 100 minus 10 curve as an early aging fingerprint. From this difference curve, we extract the statistical features such as delta Q log var, and which are shown in this table. And these features are important because these capture the early signs of degradation before the capacity fade becomes obvious. Once we have these early aging signatures, the next step is to connect them to a physical model of capacity loss. So now in this slide, we show the physics-informed capacity loss model, where X is the cycle number, Q loss X is the predicted capacity loss at that cycle. And the graph illustrates the model's physical meaning. The degradation curve increases with the cycle number and eventually crosses the end of life threshold. The cycle at which this crossing occurs is the predicted life cycle, denoted as L. The multiple curves, short life, medium life, and long life, and illustrate that different batteries can follow different degradation trajectories, and a battery with faster degradation reaches the threshold earlier, while a longer battery reaches it later. And the next step is to, now that we figured out how to calculate the predicted cycle life, the next step is to learn how to map these curves physical parameters. So for that, we use a attention-based prediction. On the left, we start with the early cycle features extracted from the delta Q curve and the capacity fade slopes. Then these features are passed on to the attention model shown in the center. The purpose of attention is to adaptively weigh the input features. This is important because not every battery reveals its degradation behavior in the same way. So the attention model outputs predicted parameters A and B. These are then passed into a capacity loss model shown on the right. This is the synergy of the proposed method. The attention models provides flexibility to learn from the data, while the physics-informed equation ensures that the final prediction remains interpretable as a degradation trajectory. To stabilize this learning process, we use a two-stage training strategy. The model is trained in two stages because the reason is that cycle life depends non-linearly on the parameters A and B. In stage 1, the model focuses on learning the degradation parameters. In stage 2, the predictor parameters are passed into the physics model to calculate cycle life. This stage process improves robustness by separating parameter learning from final life cycle refinement. Now we can evaluate whether this framework actually improves prediction performance. So these are the results from our study. The primary test RMSE for my method is around 127.83 cycles, and the secondary test RMSE is around 179.92 cycles. Compared to the ElastiNet baseline, the proposed model reduces error only by approximately 68% on the primary test set and 60% on the secondary test set. The key interpretation is that combining attention-based feature weighing with a physics-informed degradation model improves both accuracy and generalization. And importantly, this model provides more than a life cycle bird. It can also reconstruct the full degradation trajectory. Now, this results to the main conclusions. To conclude this study presents a physics-guided attention framework for lithium-ion battery life cycle prediction. Then the first takeaway that the hybrid model predicts the degradation curve before calculating cycle life. Looking forward, this framework can be extended in several directions. Future work can include other battery chemistries, explicit temperature effects, additional degradation mechanism, such as lithium plating and mechanical stress, and transfer learning for new battery datasets with limited cycling data. And thank you for your attention. I'll be happy to take any questions.
Right, any questions?
This just came in, so.
I have a couple of questions.
Sure.
So how many cells do you train to validate?
So our data set had around 84 in the first test. The second test had 24, like around 120, something around 120 cells. The data set.
Same form factor or mixed?
No, the first 100 were from the same form factor. The last 20 were from random form factors.
Okay. So you mean in a real battery management system, right? So the prediction needs to be cheap and faster.
Yes.
So how does your system work?
So in our case, we have we just don't run the entire. We don't need the entire cycles, like around thousands of cycles. We just need the first 100. So that brings the testing process to very minimal cost. So that helps us to build the entire degradation trajectory based on only just the first 10 to 100 cycles. So our process is very much simpler and easier to.
Is it cheaper?
It's cheaper too.
Okay, cool. Thank you.
Thank you so much.
There are the fourth presentation of this session, but instead of going one by one, is there any presenter here with raise your hand? Is there present before session one?
You have a presentation. Let's start with your presentation.
There are other sessions. Is there one left for this session more? Because there are 16 and I don't want 14 and
Yes.
I don't want
If you can check the names.
is Naya Sharma here?
Naina Sharma.
Is Omar Khater here? Is Gunjan Vincent Rantepi here? Is Meta Carlos? Is Roish Patel? Is Rita Sharma here? Or is Renish Rayada?
So there's a short tea break in between. The presenters will join soon.
Okay. Let's also have tea.
Good people are enjoying your conversation.
No. Wonderful.
Were you able to send the PPT to me? Who's presenting next? Okay, he's out.
But I think you should hold a conversation here for this.
Yes. Well, you were on mute.
मैं बोल रहा था सब पिंक पहने प्रदीप वर्मा ब्लैक पहन के आ गए हैं। Pink
You are
is pink.
live.
Four presentations are over or three.
4 presentations. 3 presentations are over.
Three presentations. We are trying to upload those PPTs for the next section on Google Drive.
Yes.
I'm asking all of them.
Cellular is also. Inside the cell is also. The walls are stuck.
Would you like to go next?
I think it's better so that's allowed to call again the missing ones.
Yes, yes.
So that we won't be set.
Yes, absolutely.
Possession, you know. Just for this month, but you will present. Okay, okay, you can put details into presentation.
You can forward your email, you can mark your PPT to us so that we download your PPT, you can present it. What's the name?
Pratish Nair.
Prateek Nair.
There is anyone that present that's first question.
Please settle down, everybody.
Please have the presentation going.
Send you the email.
Send me the email.
Anyone from the first session apart from you? Yeah, if you have, please send the lady the presentation, because we gave her a cover break. We found another platform.
And what is the email ID? Do you know?
In Sharma 9. I repeat, all the presenters, please send your PPTs to msharma9@met.edu. I repeat, that is MSHARMA numerate 9@met.edu. Everybody please set the, so that we can start the presentation again.
Well, I am here at cover break.
Yes, 9@met.edu.
This is right, ma'am. Sorry.
So it's Sharma 9. Yes.
Thank you. Yeah, listen.
You have sent? Sorry, you have sent? Just wait for 2 minutes. Excuse me, may I have your name, please? Again? Pratish Nair. I have not received your mail yet.
Didn't receive.
No. It is though it is still on the way, so must be in transit.
Answer, yeah.
Yes, I received also the sanction of those.
Yeah.
We are five now. All five. We will. My friend should be there because I have a session.
I know. I will find seconds.
That's the process. 41, not sanction.
Unless your whole session can sign because your name is also there, so I will sign that.
Okay, but I signed. Could you please print out again?
It's okay.
Did you get it?
I can even write conflict of interest.
Mhm.
To my part, really, conflict, I can write conflict of interest. Not to take it out of regulation.
It's okay, don't worry. There'll be third session chair, so three of us can sign.
Only for sessions.
You can do that.
And external company comes in and evaluates.
Evaluate, absolutely. So what I'm saying, I'm the third session chair. So it's okay, no worries.
Give low grades to my school. Fine.
Yes. So the next presenter is Ritesh
Let's
Nair.
wait for 3 minutes more.
She's out. Session chair.
Yes. We give them a break for 11.
Okay.
What did you feel? Nothing. If he's not coming, I will leave.
We'll wait for him, don't worry. No worries. Ritesh, if you can check this, your PPT?
Yes.
Yeah.
Do you want? Add me,
No, it's okay. It's sorry. quick check. PPTs are visible to everybody? Yes, ma'am. Thank you.
Yeah, it is visible.
We'll wait for 2 more minutes. We are waiting for our session chair, who's just gone out in search of a network.
Oh, wonderful.
So, maybe is this second because is the post session can start for example start. You know what?
Let's wait for
Huh?
30 seconds.
He'll probably come. That we have 2 session chairs.
Oh, yes. Yes. Ritesh, meanwhile, you can
Yes.
just give your introduction so that everybody knows who you are.
Today, we continue this second part of our session with paper operation engineering and please story in the current state.
That's correct.
Then the study is entitled Zero Knowledge Compliance Architectures for Grants Preserving the Systems. The floor is yours.
Thank you. So, good morning, everyone. First of all, thank you, MT, for giving this opportunity. Today, I want to present zero knowledge compliance architecture for, for preserving. We want to present the paper on zero knowledge compliance architecture, compliance for decentralized finance. This is to preserve, DeFi systems. This paper we put together along with my co-authors, Palash, Raju Srivastav. This one is. Sorry about that. So I'm just restarting. So today I'm here to present a paper on zero knowledge compliance architecture for privacy preserving DeFi systems. This paper we put together along with my co-authors Palash, Raju Srivastav, Sushmita Chatterjee. So we all know that DeFi or decentralized finance is a new way to handle money using blockchain technology. It allows people to interact peer-to-peer without a middle person, and we can do lending, borrowing, trading, and managing assets using DeFi system. And also, it also includes smart contracts, and it has good transparency. But the major problems comes there. The transparency again, it exposes every transaction what you do, and which creates a privacy risk. And again, this in turn puts regulatory pressure. Global authorities are demanding identity checks, monitoring, which threatens the decentralized nature of these platforms. Again, adding a compliance layer often requires a trusted middleman, which contradicts the goal of peer-to-peer financial system. So this is the problem we are trying to solve here. Do you guys know what is zero knowledge compliance? I'm sure you know. So simple, right? If you have to explain it simple, the one party has to prove the validity of the statement to another party without disclosing any underlying sensitive information. How can we do that? This can be done using zero knowledge compliance. So there are 2 practical adoptions for this method. One is ZK Snarks and ZK Stars. right? And CK snarks is very light, and it burns the gas very minimal. Gas is nothing but burnout. And again, it needs a trust management, centralized trust management system. So that's a constraint here. ZK stacks is, again, scalable transport arguments of knowledge. It doesn't need the centralized trust setup, but it is for the future ready. It's future ready and offers post quantum security with scalable proven complexity. Again, so this core properties of ZKP fulfill completeness, soundness, zero knowledge. However, and also it is applied to DeFi compliance. Like it can prove KYC compliance without revealing identity documents. It can prove AML clearance without exposing transaction history. It can prove geographic eligibility without disclosing exact locations, and prove aggregation without revealing financial records. So moving on to literature review, right? So all through the paper, you will come across these 5 components. Mainly, these components are evolution of privacy preserving mechanism in blockchain. First one is zero knowledge proof system, which we have seen ZK snarks and ZK stars, right? Next one is decentralized identity, DID. So blockchain enabled identity registries with variable credential allows user controlled data ownership. That is selective disclosure, right? For example, right, if you're going somewhere and you need to prove your age, traditionally you have to show your ID, where your full name, address, and your age is disclosed. But here, I mean, with this, you can only verify, it will only give you the date, age 21, says, I mean, it says it's valid and you can get the entry. So, and then smart contract compliance. So again, it's a programmable compliance, automates regulatory enforcement through the code. So this, what it does is, compliance can be enforced through a code, right? Eliminating centralized centralized authorities, right? And this one is cross-chain interoperability. So SKP based on cross-chain compliance models enables privacy preserving data exchange across the heterogeneous networks. And latency, trust, assumption, and standardization remain a key challenges for this mass adoption. And again, oracles and data integrity. So Oracle bridge chain of regulatory data with on-chain smart contracts for identity verification and risk assessment. Moving on to the next slide. So I want to highlight the research gaps here. There are 5 persistent unresolved research gaps, which we are trying to solve, which we'll try to solve. Hello, sorry about that. What was that? Okay, if you're not, all right, okay, thank you. Scalability limitations. Yeah, so the main thing is, SKP infrastructure imposes heavy computational loads, which in turn affect the loading of proof. Each proof can go up to 450 plus milliseconds. So the scalability, that again in turn affects the scalability, and lack of standardization, right? The absence of a authority or a unified standards for decentralized identifier, verifiable credential, or cross-protocol compliance procedures creates a severe interoperability barriers, like WC3 standards. So there is a lack of a standard authority, and Oracle trust dependency. So Oracle, supports off-chain compliance data to validate off-chain compliance data like sanction list, risk source, regulatory status, and so on. But it can act as a single point of failure, right? If this fails, whole whole compliance structure fails. So there's again a gap, and regulatory uncertainty. The absence of a formal legal frameworks recognizing cryptographic proofs as a legal admissible compliance evidence creates a structural barrier to adoption. So it is legally not adopted everywhere. So that is another challenge. And usability challenges. So because it's cryptographic complexities, the adoption is slow, and user experience is difficult. I mean, people experience difficult to adopt. So again, that is a challenge here. So that is what we are trying to address with our framework. Before that, we will look at it. Look at the current basic ZKP framework. The current state is, key components involves decentralized identity, blockchain-based smart contract systems, and privacy, and zero knowledge proofs. This is layered. It has a layered architecture. The first layer is user layer, where the user receives verifiable credentials from a trusted identity. And the second is the protocol layer, where the smart contracts acts as a compliance gateway. And the next third one is scalability and data, where Oracle comes in picture, Oracle mechanism comes in picture, where the validation is done. But there is huge limitations here. Despite the methodology is good, it has weakness too. So first weakness is relying on semi-trusted credential issuers, which reintroduce a single point of failure. And then proof generation is very slow. That is roughly needs 250 transactions per second. And then credential standardization, again a gap. It remains unclear of legality, how it is enforced, and how it can go globally adopted and across the globe. So that's a challenge. So here we are trying to propose a methodology called as zero knowledge compliance framework. So the proposed framework will try to address all the 5 identity research gaps through unified 5-stage of pipeline process, where first one is modeling, where the data is inputted, where the modeling or normalization, it uses a standardized schema to convert all the heterogeneous user credentials or regulatory constraint into single uniform format, and ensuring the interoperability. And then next one is generating the credential, and then consensus, right? I mean, what it does is, rather than depending on single point of Oracle dependency, with a consensus-based validation mechanism is applied, where aggregation of multiple independent Oracle responses is taken into consideration, so that data integrity and tamper resistance is intact. So aggregate again, the 4th stage is aggregation to handle high transaction volumes. The framework employs a roll-up based aggregation model that matches multiple proofs into a single validation. And then final is the verification. The final stage uses the smart contracts to automatically authenticate, aggregate evidences, triggering valid or invalid. And if it is valid, it creates the credential. So this is the framework we are proposing. Again, so to maintain the speed and privacy, heavy computation and data processing occurs off-chain, while the final validation and settlement occur on-chain. So if you see data normalization, again off-chain, it is done. ZK proof generation off-chain, and Oracle consensus is a hybrid where it can use both off-chain and on-chain. And roll-up aggregation, again, it is off-chain, and verification and execution, again, on-chain, on the blockchain, So following up the mathematical formalization we used for different stages. First one is compliance vector normalization, what you see. And then second one is how, the zero knowledge proof generation happens. The third one is decentralization, Oracle consensus. And fourth is roll-up based proof aggregation, and fifth one is smart contract verification. So we did, did a research. For this research, we used multiple data, a combination of data from a stimulated test environments. We used synthetic data and also open source development tool chains in details. And we tried to model it on the real world DeFi scenarios. So we benchmarked based on 4 models. First one is a traditional DeFi compliance model, right? And it's fully transparent on-chain interaction. And next one is CKYC, YC, that is centralized KYC. And then basic ZKB, that is basic zero knowledge proof model. And then when we use the ZKCF, that is zero knowledge compliance framework, that is proposed model, and we have seen the throughput, the throughput is high, 420, that is 420 transaction per seconds. And proof generation, again, it is 220. It takes only 220 milliseconds, and verification is milliseconds, right? So ZKCF achieves 68% increase in throughput over basic ZKP models, having proof generation time. And then results comparison, right? This is the result comparison between all the models visually displayed. And then if you do the analysis of security and compliance evaluation, so the privacy score is up by 96%. Decentralized index is at 0.9. And compliance accuracy is at 98%. So discussion, this is the comparative, right? I added, between all the 4 frameworks. So the thing is, we with these results, right? We are proving that zero knowledge compliance framework effectively solves the trilemma of balancing privacy, compliance, and performance in DeFi. So, the key drivers are proof aggregation, decentralized Oracle consensus. These are the 2 big twins. And again, it achieves 420 TPS, 96% privacy, and 98% accuracy. Conclusion is, so the research concludes that zero knowledge compliance framework, successfully bridges the gap between strict regulatory enforcement and user privacy. We have come up with a middle ground, where we don't completely expose user information, but we are meeting all the compliance. And the core findings: architectural success, right? Normalizing zero knowledge proofs, decentralized oracles, all this is architectural success. Proven performance, we have seen, we try to replicate the real world scenarios, and we got good output. And efficiency, right? Efficiency, again, it's 220 milliseconds for a proof generation. That is, again, a big win. And the only key implications are, for regulators, authorities can verify that rules are being followed through cryptographic evidence without overseeing the user's raw data. And privacy, again, score is up for industry. The current framework demonstrates the innovation and regulation can coexist, allowing for secure and compliant and private financial transactions. So future scope, extensions, limitations, and research directions. So using specialized chip, like if you, the area where we need to explore more is faster hardware, using specialized chips to speed up proof generation from hundreds of milliseconds to nearly real time. That needs to be explored. Global standards, we need to come up with a unified rules for digital IDs. So compliance work across the globe, right? And across the blockchain chains. And AI risk assessment needs to be added, integrating with machine learning and to detect the suspicious activity. Again, that will benefit the framework. And legal integration, building a system that allows regulators to audit compliance through cryptographic evidence without ever seeing private user data needs to be explored. So again, current limitations are rigid rules, speed bottlenecks, and user complexity. So these are the references what we used for the paper. Thank you. This was our paper, and if you have any questions, let me know. Thank you.
This is for the audience. There's one.
Sure.
In terms of the outcome that we showed,
Yeah.
and percentage of outcome, that the improvement of the realistic data, or you can create some kind of test information to get your model.
So yeah, so it's a combination, right? We simulated some test data, we got the synthetic data and open source development tool chains information. So all that is used to come up with we got the test set from there, and then we tried to prove this framework.
Any plan? Your model is taking a realistic information, like the realistic transactions.
We did minimum, yes, we at later point, yes, we want to explore more, yes. Thank you.
Yeah. So I just joined late, but I read your paper before. I have a couple of questions.
Yeah.
So what is the proof system that you're building upon? Like, is it gross or long or short? What's the proof system?
What is that?
What is the proof system that you're building upon?
It's we are using two, ZK Stark and ZK Snarks.
Okay. And how does your architecture compare against the existing solution like ZK?
I mean, yeah. So this is the earlier version where is basic ZKP, we can call it as, and we are adding additional pipeline model where some of the some of the process which takes a lot of computation is taken off the chain. So this is the pipeline model which we are trying to propose, where the first data normalization happens, and then we do the generation, and some of the things which in like Oracle consensus happens off the chain. So we are reducing the number of transactional time and also computational capacity. I mean, it doesn't need that computational capacity. So that's how we are proving this. Earlier version didn't have all this. So the new this is what we are proposing, the pipeline model. Thank you. Thank you all.
Who's the next? And the next paper. Here, titled AI-based analysis of factors affecting unemployment in the UK, a regular site regression approach, will be presented by Shreya and Tulita. Please bring forward statement. Yeah.
Give it to me.
Yeah, I did send my receipt. Received. Okay.
Why you not doing? Why
Vidushi Chandra can present, but she's
About from the newcomer, Is there any more paper for session one, this session? You have. Yeah. While the operation is done. Sorry.
Dr. Navleen, what is your paper ID?
115. That's your paper, right?
Let's see.
Online, if you can confirm the PPTs are visible to you. Is the PPT visible?
Yes.
Yes, ma'am. It's visible.
Thank you. Over to you, Dr.
Navleen Kaur paper, yes, ma'am, visible.
Check.
It's the presentation while you're preparing, the new presentation will be AI-driven multimodal healthcare wearables for value-based healthcare monitoring and finance. That's the Dr. Navleen.
Yeah.
Please, the floor is yours.
So very good morning to all of you out here in US, and very good evening to everyone out here in India. So I'm going to present on the paper, which is AI-driven multi-modal healthcare wearables for value-based healthcare monitoring and financing. So what we are talking in this paper is about the healthcare wearables. You can just have a look at the pictures. These are the very famous healthcare wearables that we have. We start with an Apple Watch, then a Samsung Galaxy Watch, or an Aura Ring, or a Whoop strap. Then we talk of the eye wearables that we have. Then we have pendants as a wearables. Then recently, Zomato's CEO, Dipinder Goyal, he was seen wearing a temple out here. A temple is a button, right, which usually tells you about your brain health. So these are the very famous AI-powered wearables which are seen in the market these days. Now, what does this paper talks about? The paper talks about that these wearables, how can they continuously monitor the health and they lead to value-based healthcare. Value-based healthcare basically means that till now, how do we monitor a particular patient? In India, we monitor a particular patient based on if a patient is having, let us say, any particular disease, that patient will go to the hospital. And that patient will go to the hospital and tell that this is the disease that I'm suffering from. You can please cure me. And then number of treatments are given to the patient, and then the cure, it happens simultaneously after that. Now what we are doing is, in this paper, we are trying to monitor a particular patient based on the wearables that a patient is wearing, right? And we want that the health of the patient should be fine, right, from the very beginning, instead of he going to the hospital after the things they have really gone worse, right? So this is the idea behind the paper. So what all things that we can do? In this paper, we talk about the multi-model. What is multi-model? If you see the topic of the paper, it is AI-driven multi-model healthcare. What is multi-model? Multi-model basically means collecting different type of health data. Now, what kind of health data? For example, heart rate. It can be the sleep pattern of a person. It can be the activity of a person. It can be the temperature of a person. It can be the stress level of a person. So everything we are going to study of that particular person How we are going to do that? We are going to do that through AI, that is through artificial intelligence. Now, what was the problem? The problem was that healthcare system was largely reactive. And what we are trying to do, we are trying to make it proactive. This is the problem that we identified. Value-based healthcare, again, doctors, hospitals are paid based on number of services provided. Now, what we want, that the payment should depend on the patient outcomes. That is, the focus is on better health results. The focus is on prevention. The focus is on reduced hospital visits and long-term wellness. This is what we're looking forward for. This kind of model, that is value-based healthcare, it is still not there in India, but in US we were trying to find out. It is there in the Mayo Clinic. In US, they are following it, right? And then we are trying to bring that to India too, so that our probably healthcare system should improve and the health of the people should improve. What was the research gap? The paper says earlier study mostly focused separately on technology design or consumer behavior. There are very few studies who talks about AI variables, user acceptance, and value-based healthcare financing together. So, again, I'll focus on one thing here, that is value-based healthcare and then financing. What exactly is financing in this particular case, right? Now, the financing in this particular case is the healthcare payment system. How the doctors, they are going to get paid. That is what is financing. This is the part that we are going to focus on. How the doctors would be paid. The payment model would be bundle payment and pay for performance. Through artificial intelligence, the patient would be monitored, and if the doctor is able to keep healthy patients, more the healthy patients, better is the salary. Right? More the healthy patient, better is the salary. Instead of this thing that the patient is coming and then you're telling the patient to stay in the hospital for two days, 3 days, 7 days. Not on this basis, but it has to be value-based healthcare. This is what exactly the financing is. So we talk of bundle payments and pay for performance. So what we have done an online questionnaire survey here, and 220 respondents were there, and the model that we have applied, it is a UTOUT model. This is a model that we have applied, and through the questionnaire we tried to find out the performance expectancy, the effort expectancy, then the social influence, then the facilitating conditions, and the hedonic motivation. It means the pleasurable motivation that people have by using these healthcare devices, how it leads to the behavioral intention, the user intention, and then we've also covered the price value and the habit of people in our questionnaire. These were the hypotheses. And this is the statistical data. So I'll just explain you the data. 82% they said that they intended to use healthcare variables. When they were asked that, are you comfortable using it? They said yes. 76% would recommend them to others. If we talk of performance expectancy, 85% believed variables help in early disease detection. Ease of use, 92% found variables, they're easy to use. Social influence, 62% were influenced by friends, family, social media. Price sensitivity, many users were concerned about the cost. Affordable pricing is important in India. Then trust matters. People are more willing to adopt devices if AI systems are trustworthy and privacy is protected. So privacy again plays a very important role. They said that, okay, fine, we will use the healthcare variables. It is good for our health, but privacy should play a very important role. So the conclusion of the paper was that AI-powered variables have strong potential in India. People are ready to adopt them. These devices can improve preventive healthcare. They can support value-based healthcare financing models. The studies strongly support the future use of AI, smart wearables, remote monitoring, and preventive healthcare system in India. what is the future scope? Low-cost AI wearables for wider healthcare access. If more and more people, they start using all the AI wearables, in that case, we have a future scope that we can bring more wearables, seeing the population of India, it is not that much used in India. And then if we can reduce the cost of those wearables, then we can also expand to rural healthcare systems. This is one thing that we can do, which is very important. In India, we also have Ayushman Bharat Digital Mission. We can also associate with them. Then use of advanced AI and secure technologies. We can use the blockchain federated learning. Then more long-term clinical studies on health outcomes. The limitations, right now we have done our research on the urban population. Probably with times to come, as these variables, they are going to be more famous in India, we can also target the rural and low-income population. And these are the references that we have referred. So that's all about it, our idea. If you have any doubts, any questions, you're most welcome to ask. Thank you so much. Yes, please.
So how feasible do you think that model be used?
I think this model is going to be very feasible. Absolutely. I think this is going to be very feasible, because it's already used in US. Mayo Clinic is already using it. And this is the motivation that we had. What we want, that number of times in India when we see, let us say a patient is required to be in the hospital for 5 days, and the patient is asked that probably you stay here for 7 days, you stay here for 8 days, because the payment system is based on that. So we want that instead of this, if we follow the same approach, that is value-based healthcare, that is really going to help a lot in India, seeing the population. So this is, we have seen the feasibility out there in US. Based on it, we try to adopt. And then we are also trying to understand these systems in various countries. So the times to come, if you go through these value-based healthcare, many countries, they want to adopt this thing. And this is the reason that why these healthcare wearables, they are becoming so important. You can see so many of them, they're wearing it because they want to monitor themselves in advance. If you see in your mobile phones, you have step count. This is one of the things. And you always want to ensure, okay, fine, today I should have those 10,000 steps, What is the idea behind it? The idea is so that I should be healthy. If a diabetes of a particular person is monitored in advance, right, so that particular person can be healthy in the future. And if this AI can be monitored, it is not like the doctor has to monitor it. Doctor has to look all the time. No, every task will be done by the assistant and the AI. Once the bell rings that yes, this particular patient is not doing that well, the doctor has to jump there. So that is what is known as value-based healthcare. And if your patients, they are really doing very well, you should be compensated based on that. So this is the idea. Anything else?
Okay, I have a few questions.
Yes, please.
So what is the comparative? Is it a standard care or episodic monitoring or less rich variables? So what is the comparative?
The competitor of what?
And what are we trying to compare it with? Is it with the standard care or is it
We are,
sorry.
yes, no. We are comparing it with the standard care. Why are we comparing with the standard care? Because in case of this is what it is happening, right? What we are trying to do is, right now we are comparing it with the standard care, that if any particular person is having any particular issue, right, and we monitor it in advance, right, in that case, probably his or her health can be better. This is what we're trying to do. But I have noted this thing out, that whenever we're going to do this future research, we can even bifurcate it into, let us say, this is an episodic care, this is a standard care, and then we can move one step ahead. We can always do that.
Okay.
That's it.
Thank you.
Thank you so much for listening.
Thank you, Dr. Bain.
Follow-up question. Please.
Yeah.
Yes.
Yeah.
For the value-based compensation to the providers, did you guys have a chance to talk to any doctors?
We talk to the doctor. Few of them they were hesitant because know how the way the things are. But then if they are, because It's always convincing them. Oh, if you only do that, and then few who are very, very honest, they're really blessed. They say yes to something like that because for us, our major motive is the health of our patients. We don't look at the forward process. We want something better if we can get. We had a word with them. Thank you.
Thank you, Dr. Naveen. Our next presenter is Shreya. Shreya, just check if your slides are correct. These are the slides? Yeah. This was the slides, right?
Yes, ma'am. Can you slide?
Visible.
Thank you. Just a second. Here you go. Okay.
Good morning, everyone. I'm Shreya Kathuria from Amity University. My topic for research is AI-based analysis of factors affecting unemployment in UK, a regularized regression approach. In this research, I was supervised by my professor, Dr. Anant K. Jaiswal. He guided me very well. This work focuses on forecasting unemployment using machine learning and statistical regression techniques, especially in situations where economic variables are highly correlated. The UK labour market has faced 4 major disruptions due to 3 major events. The 2008 financial crisis, Brexit. What was Brexit? Brexit was the withdrawal of the United Kingdom from the European Union, and the COVID-19, which we are all familiar from. These events created unstable employment patterns, making forecasting very difficult. Traditional models like OLS regression often fail when predictors are highly correlated. In my dataset, I observed several multicollinearity, which made coefficient estimates unstable. This motivated me to use regularization methods like Ridge and Lasso, which are better at handling correlated data. The research gap is the previous studies usually tested these models separately, but no study compared all the 5 models all together. This slide summarizes previous research related to unemployment forecasting. Earlier studies introduced techniques like Lasso and Ridge and showed that regularized methods often perform better than traditional regression using structural changes or multicollinearity. Just like Mr. Tipshirani introduced Lasso, and Jiang and others found that Lasso was better at structural breaks. However, most studies focus either on different countries or on limited model comparisons. Okay, so this study addresses 4 major research gaps. First, most earlier studies used non-UK datasets. Second, many focused on only 1 or 2 model types instead of comparing all approaches together, which I am doing in this one. Third, very few studies combine autoregressive persistence models with regularized structured models. And finally, limited work used long quarterly UK data from 2001 to 2005. To address this, I have compared 5 different models using both in-sample and out-of-sample evaluation metrics. This figure shows the complete modeling framework. First, the quarterly dataset was divided into 2 types, the training and the testing. Training was 80% and the testing was 20%. Then, VIF analysis was performed to identify multicollinearity among predictors. After pre-processing, 5 different models were trained: AR1, AR3, OLS, Ridge, and Lasso. Finally, all models were evaluated using R-squared, in-sample RMSE, that is root mean square error, and out-of-sample. Among all these, AR3 achieved the best forecasting accuracy, while Lasso performed best among structural regression models. This table compares the performance of all the 5 models. Although all models show similar in sample accuracy, but see the out-of-sample performance, it was very different. The AR3 achieved the lowest out-of-sample RMSE of 0.0977, You can see I have marked the star, making it the best overall forecasting model. OLS performed poorly with an RMSE of 0.5007 because multicollinearity caused overfitting. Ridge improved performance slightly through coefficient shrinkage. Why I chose LASSO? Because LASSO achieved an RMSE of 0.1927 and emerged as the best structural model. This graph compares in-sample and out-of-sample errors. OLS shows the largest gap, meaning it overfits the training data and performs poorly on unseen data. Ridge reduces this gap using L2 regularization. LASSO shows the best balance between training and testing performance because it removes unnecessary variables through L1 penalization. This graph shows actual versus predicted employment values using the AR3 model. The fitted values closely follow, and real employment trends, including the 2008 financial crisis, post-crisis recovery, and the COVID-19 spike. This confirms that past employment values strongly influence future employment in the short run. However, AR models cannot explain which economic variables are responsible for these changes. This slide explains which variables were selected by LASSO. LASSO retained only 3 important predictors. Like I said, it removes the unnecessary variables from the while testing. Lagged unemployment, wage growth, and labor force participation rate. Lagged unemployment had the strongest coefficient, showing persistence in the labor market. This is one of the major advantages of LASSO. It automatically removes less useful variables and creates a simple, more interpretable model. And the conclusion, AR3 achieved the best overall forecasting accuracy. OLS failed due to severe multicollinearity. LASSO delivered the best structural performance and significantly outperformed OLS and Ridge. This study also suggests that wages and labor force participation are stronger indicators of unemployment than GDP or interest rates in UK. Therefore, policymakers should definitely focus on labor market indication while designing employment policies. In future work, this treatment can be extended using the rolling window estimation, regional UK analysis, deep learning models like STM, and one limitation of the study is the small data set size and the assumption of linear relationships. These are the references. Thank you.
From the audience that you would like to direct to your follow-up. Any question? Any question? Here, could you please amplify what are the future directions of your study, especially in terms of real applicability and
Basically, I try to cross-validate by including other European countries. Right now, I just focused on the UK part. I'll introduce more countries and basically integrate all of them and try to integrate in one more and more as possible.
What kind of differences do you expect compared to the improved country like UK when you implement the solution to an unimproved country?
Like employment works on basic factors like wage growth, the rise in economy and the decrease in economy. So I'll study that and then include all of them.
Thank you. Do we have the Schumann are there missing some like very briefly Naima Sharma or Omar or Lunsha, Ronish or Alfal? That's it. For this session, thank you very much for your participation. That the rest of the conference for all the presenters will go well and it will be a fruitful one. Thank you very much. Thank you. Great, for something I don't know for the rest. Oh, enjoy the good. Thank you.
No, I didn't. Yeah, it's very. Okay. I can also stay for Oh, hi. Thank you. Also the main ones and nobody's say that enjoy beautiful guys. So they're very much so you know that will be all from outside. Yeah.
So we'll proceed with the next presentation. We have one more presentation here. Have you shared a paper?
Yeah, I shared to, I think he sent me a Google Drive.
Okay, you have uploaded on Google Drive. Dr. Nikhil, can you very quickly mail me the Google Drive link? I saw it was on WhatsApp. Can you please mail me the Google Drive link? Who's there? Dr.
Yeah.
Nikhil?
Yeah, tell me, ma'am. Yes, Dr. Pinga.
Can you mail me the Google Drive link?
Okay, I'll mail you. I'll mail you right now. I'll mail you.
What is your paper ID?
191.
Can I also ask for name, please?
Soma.
Soma. Oh, if you can quickly share 191, paper number 191, Soma's paper, right? You're done with your presentation?
No, I have, as per my schedule, it's tomorrow.
It's
And also, how mandatory it is to follow the exact template. I have a similar template. It's fine. And my presentation is at 11:45 and probably close off. Is it possible to push it a little earlier tomorrow?
Why don't you do it right now?
Right now?
Do it right now.
After the break, probably?
Yeah.
Okay. I can give at least one.
How many papers you have?
So both the papers can be presented today, sir? Time permits?
So now if you can check, this is your paper, these are slides? Okay, I'm just sharing it.
So let me forward my presentation to you.
Yes.
M Sharma 9 at MIT.
Visible. Soma Sandram. Suryanarayanan.
And now the person with the most questions will present.
Oh, no. I mean, I was reading all the paper because you selected me session chair, so I have to.
Very good, very good, very nice.
Yeah, Mr. Normally Soma and presented the second session. We will present at the end of the session in this paper entitled Concentrate Prepared During Climate Infrastructure. Soma, the floor is yours whenever you're ready.
Okay. Hi everyone. So I know we are very good here. So maybe we can make it more interactive. So yeah, I am Somu Suryanarayanan. So I'm a staff QA automation engineer.
Would you like to come here so that people who are online, they can also be there?
Oh, nice.
Yes.
Yes,
Hello everyone.
Hello, Soma.
Hi.
Please continue.
Sure. Give me 1 minute. I'll just minimize it.
Move it. Yes, minimize.
Hello everyone. I am Somu Suryanarayanan. I'm the staff QA automation engineer at Cook Unity. So I'm basically from California. I came all the way here to present, and thank you all the great judges, and I'm so honored to be here. So my paper is 191. It's basically an industrial case study whether each and every company should start investing in a commercial platform or an in-house AI tooling platform. So I'm sure most of you are using web-based application. So this is going to be of that sort. So let me go to the next slide. Yeah. How do I go to the next slide? Oh, okay. So as we all know that with the evolution of AI, like every company started to think like whether they wanted to invest into AI, build their own tools, or they wanted to buy tools from online. So I think that was something every company started thinking about it. So me and my team evaluated almost like 10 to 15 tools, and we came up with an evaluation. So a high level evaluation is that like, so basically we wanted a QA testing platform tool, and we got around like 15 evaluation. And the one biggest risk is that like a simple login takes around like 4.5 minutes, and 2 or 3 test cases were failing. And the most important factor is that like in order to purchase a vendor tool, it's costing around like 70,000 US dollars. So ideally, like if anybody wants to purchase a tool, whatever the team is committing upon in the paper, like marketing, is miles apart from what is actually happening in the experience level. So that brings us 3 research questions. So how does the speed and the reliability on an identical scenario, and how does the capability covered across all the testing type, and what is the 24-month total cost of ownership? So with that question being said, so we started evaluating more and more of tools which all offers natural language test authoring with self-healing. And we also have, they also provide some of the visual validation, semantic validations. I also did some of the academic research where I wanted to understand how the LLM hallucinate all by itself. So I got a report, it is somewhere around like 34.3% of, hallucination happens. So this clearly means that there is no peer-reviewed production level comparison of how or what the commercial platform versus in-house AI tooling platform. So that is a gap. That is what this paper covers. And here is a 3-layer methodology, which is what we built. So the first layer is basically the AI layer. So the AI layer is basically Claude AI and the Codex AI is talking to each other. And then we have the orchestration layer. That is where all the generate execution and the review things happen. And then it goes all the way down to the repository, web and the mobile. And then we have the knowledge base. The knowledge base is where the hallucination has been reduced. So it keeps up to the top layer of test studio. So, and then we evaluated with 3 major scenarios. The first scenario is logging. As you all know, we wanted to log into an application and see how fast it works. So pretty much comparing with the vendor tool takes around like 4.5 minutes, but my in-house platform takes around like 45 seconds. So the same thing happened with an end-to-end checkout flow. Basically, like you log into an existing application, and then you add an item, go to the end-to-end test cases, happens in like 1.3 minutes in my in-house tooling, but the same thing happens in like 16 minutes. And most of the things were failed. Same thing for the new user sign up as well. So extrapolating that to 100 test regression case tooling is somewhere around like 70 minutes, whereas the commercial platform is going around like 10 hours, which is miles apart, right? And the second result is basically the mobile testing. So honestly, like it was pretty shocking for us because there were no commercial platform providing support for native mobile. So we built in-house mobile system, which we automated 70. And remember, I was talking about the hallucinated part, right? So we just defined a route. We wanted to reduce the hallucination through AI. And that's why we just kept our knowledge bases that helped in increasing the success rate to 91%. That keeps us the mobile testing more secure. And now comparing the cost analysis. So the cost is basically for a vendor application, it's like 130K, whereas what we have in house is like 2 to 3K. Basically, what are all the tokens? That's all we are using. And comparing to all the 24 months, it's 60 to 75% cheaper. And this is actually the capability that we wanted to cover. So the gap in the industry, that is what we are trying to address in this paper. So honestly, we are able to build more and more of capability coverage when we have a tool in house. And yeah, so when do you actually build and when do you actually buy? So assume that if you have an automation framework, or if you have a tool or engineer, and then you have things in place. So start building the test studio. If you don't have any of those things, buy something, and then you don't want to stop the production. So until then, you can just keep writing all the test cases. And once you become stable, then you start building things. So when you always go to a vendor, you have a lot of gap. Basically, they do not have the mobile testing gap, and then you have a vendor login, and then you have a maintenance as well. So all in all, if you build a tool all by yourself, it is actually six times faster, and you can have more capabilities, and it's less cheaper. I mean, almost like 70% cheaper. Of course, with AI, you have a lot of future scopes. So the very first thing which I can say is, for myself, we are going to build for Android, and then we are going to build a production health monitoring and whatnot. I mean, we can build as many capabilities as we want when you have AI in-house. And yeah, that is it. Maybe you can ask questions. Thank you.
Any questions? So you're presenting and also you're session chair.
I mean, very good questions. Yeah, my presentation happened, but since it was a very long status on you, so I was fine.
Oh, your presentation was scheduled for. So good.
Yeah, I want to why you have two session chairs. One is there, one is that, but it's not conflict of interest. So I can.
Good, very good.
And we have eminent session chairs.
Yeah.
Everybody qualifies to be the session.
Yeah, session is just a border.
Because you got it. Saying that in India, there's a very famous actor by the name of Ram Kapoor. So my people are asking me, is Ram Kapoor presenting famous?
Yes.
I'm talking about it. Yes. So I would say very proudly, yes, Kapoor is representing
Thank you very much.
Thank you.
So,
Who's next? Madam, what is your paper number? 230. Have you uploaded on the drive? Okay. She's made it. We are so happy that you have come from Hyderabad all together. We are so happy to have you here.
Take there too.
yes.
Is the slide visible?
Yeah, it is visible. Dr. Surya Kalavati.
Dr. Surya? She can come and present. So her name must be.
Yes.
Oh, yeah.
She's coming.
No, because this and all, I don't know. I thought it was
Yeah.
No,
Oh,
yeah, that's what
Everybody is so excited. No, she has not bought sweets for anybody. She only has bought research paper for everybody. Here you go. Yeah, you can start from. Please, you can start from here. You take the smart photo. Yes, yes, you'll get multiple photos.
Please keep the photograph.
So good morning, all of you. I'm a professor from Jawaharlal Nehru Technological University, Hyderabad. So on behalf of my students' PhD work, I'm going to present this one. So this is nothing but where nowadays we are, maybe we are going for distributed generation. Maybe distributed generation, we are using solar, wind and all these things. So this is the where we are using PV cells. And from that one, that is solar energy is by using PV cells, we are converting into the energy. So in this particular case, so we are using so many converters. So that is DC to DC converters nowadays we are using. So because whatever the DC output from the PV cell, that is not a constant one. Why? Because sometimes depending on the irradiance. So that's why we are not getting constant power. So it is going on changing. So, and we get a constant DC output, we are going to go for converters, where by using DC link capacitor, we are maintaining that voltage also constant. Whatever the voltage is available at the PV cell, it is not constant. Sometimes it is depending on the irradiance, sometimes the shading is also there. So due to that one, so to get a constant voltage, and that is also sometimes we want more voltage from the whatever the PV cells we are using. Sometimes we are getting less. So for lower voltage applications, we are going for some other converters. So when we want to step up, in case of general in-home appliances and all these things, so we are using transformers, no? So similarly, here also to stepping up the voltage. So in power electronics, by using the power electronic components, we are using the boost converters. Similarly, if you want to step down the voltage, we are using the. So by using all this, so to maintain how optimized energy conversion is taking place, all these things, nowadays we are using so many optimization techniques, and slowly all the things are moving towards the artificial intelligence. So that's why we are using all artificial intelligence methods. In this one, an improved, that is class topper optimization technique based interleaved loop converter for PV framework. So in this case, so here we are using already I explained DC to DC converters. So enhance voltage levels and improve energy transfer efficiency. And here maximum power point tracking techniques are essential. So here boost converters, previously the conventional boost converters are there that are a SEPIC converter, like boost converter. These are conventional. Nowadays we are using so many other what are optimized boost converters we are using. So in this work, a class topper optimization technique method is MPPT integrated ILU converter and efficient reliable PV power conversion. We are going for this in this particular case. So in this ILU converter and that is class topper based converter. So interleaved converter which reduces the current ripples and switching stresses and improve efficiency. And ILU converter is also boost and regular PV voltage to maintain stable DC voltage. And CTO based MPPT technique algorithm. So in this one, that is class topper optimization, means we'll compare the topper students of different sessions, and depending on the term, whatever the optimization techniques we are developing, that is nothing but the class topper optimization technique, which is used. So maximum power point tracking, that is when we are getting the maximum power. So depending on that one, we are going for this. So ensure maximum power extraction. So under varying irradiance and partial shading conditions. So this is the circuit which we are representing. So ILU converter consists of two LC parallel combination with the switches as well as a constant capacitor is connected, that is nothing but C0, where that is known as a DC link capacitor, across which the voltage is maintained constant. So this is the thing. And here to calculate all these things, it's also depending on the duty cycle, and the output voltage is 2 minus D, that divided by 1 minus D VPV. That is VPV is the voltage which is available across PV cells. So similarly, we are calculating the inductances L1, L2. And here, this is some of the equations we are getting. And MPPT techniques generally, we are using perturb observe, that is one method, and incremental conductance method. And there is some drawbacks in this one. That's why we are going for that is incremental conductance method, where we are using class trapper optimization technique. So here, there are different optimization techniques already applied. That is particle swarm optimization and gray wolf. That is one method, and another one is class trapper optimization. We are using class optimum optimization method, trapper optimization method. In this one, we are getting a good results, and the efficiency of the system is increased, and voltage gain is also maintained constant. So this is the flow chart which we are develop, and the results and analysis. Here we are considering different conditions. In level 1, we are getting the output with number of 120, and the second one number of cells 120, where the output is varied to 600 watts per meter m square. And the third one is where we are going for the shading, that is we are decreasing the number of cells to 80, so that the output which we are of all these things, that is dynamic response of DC-DC converter with CTO, and comparative analysis of the converters. And here boost plus class trapper optimization, if you compare ILO plus class optimization technique. So in this class optimization technique along with the interleaved loop converter, so it is 630, and that is 480 for the duration, and next one is that is improved if you compare both the things. And here we are developed the prototype thing also, and we compared, we are getting better results. So in this work, ILU converter is integrated with the CTO based MPPT technique for a photovoltaic system. This configuration consists than others techniques in terms of output, that is profiles and efficiency, and highlights results and highlights the importance of ILU converter. So that's why the ILU converter is used to maintain the voltage gain, and maintain the efficiency of the system, and to maintain the quality of the power. So this is the future scope. So these are the references. Thank you.
And thank you.
Yeah.
Can I ask one question? What of CTO is that? I'm very layman here. Just what is CTO stand?
What is CTO?
CTO, that is class trapper optimization technique, like a particle swarm optimization technique.
Yeah.
And the wolf optimization technique we are using. So tappers we will compare, and like that we are developing one algorithm. So we use that algorithm along with the MPPT technique. MPPT technique is maximum power tracking. So irradiance is there, and the different times the solar will be different. There is whatever the light we are receiving is different. So that's why it is not a constant. That is a non-linear power output. So to maintain that one, so we are using this maximum power point tracking. In this process, when that is a come to a stable position, at that time that is moving like that is a wave. So to maintain and to get the proper maximum power point, so we are using class trapper optimization technique.
Okay.
So this is one of optimization technique.
Okay, great.
So there are number of nature inspired algorithms nowadays. Number whatever may be, that is fog inspired, and okay, birds inspired. So many optimization techniques. So we are using not only technical, non-technical persons are also using nowadays optimization technique methods.
Okay.
So that is how best we are getting from the whatever the input. What we require, in that how best thing will extract.
Thank you, ma'am. Thank you.
Thank you.
We stayed there for almost 2 years. Then you know you're not near the very little.
I just forgot my converter from European side to US side. Trying to find a converter if there's any available. Sometimes they bring some converters to you.
Yeah. Like we are doing. So what I mean is, what I call critical confidence usually makes something like a I quickly 6 months, 6 months, because it goes into 2 months. Now we are saying that I know you're probably the farmer so it's months now.
I found what I said. Yeah, at least I can charge it from here. At least I can charge this one for you.
So, well, this give you some. You guys want to be.
Yeah.
Was a different domain, not one is going to start rather because I
straight away. So probably It was like your lunch was half year for one evening. And it is not this is the first. Oh, is it thanks to you? I'm just looking. Oh, yeah. Yeah, so I think you say that I'm proud of you, get proud. That is going to be soil. Exactly.
Yes, conference guys.
I suppose that, there'll be a
Yeah, some food.
Let's do that.
Yeah, conference where we sit.
We don't see it. Instead, we want the industrial. For these, we got three more.
I've seen here some of US, it could be conferences. But if we just skip the conference, then actually takes. And more engineering, right? They all, right, and getting everything out of.
They ask for a practice.
Let's all once again. Yeah. So the session got stopped. Yeah, that's second part. Yes, from this. First one they had asked me. Yeah, because I just found it in the ICETM explore I found that. Exactly. Confidence and that posted in something. So I can experience that.
So we have done with all the presentation for session 1. We'll again meet at 1 o'clock for the inaugural session. Thank you everybody for joining.
I just put it just to charge.
That's okay.
I could not find the converter
You
for the plug.
borrowed my laptop?
Yeah, I borrowed your laptop without asking you. I could not
That's
find
okay.
I could not find my converter is at the hotel.
Same
That-
problem with everybody.
Yeah, so that's I was trying to charge someone.
No issues.
It's mine is at hotel, but
It's okay. It's okay. We believe in collaboration.
it starts now.
It's start now. So when is your presentation? Post lunch.
It's good.
1 to 1:15. Do you want to give your presentation right now? Why don't you give your presentation right now? Then you have to attend the session. Mail me your.
Anybody who's asking, present tell me.
अभी session. Session है किसी का.
Okay. ठीक है, तो ये बोलो नहीं जो यहाँ पे कैसे चल रहे थे, जी बस asking.
तो उनको हम वहीं दे देंगे ना, सबके सामने सबके हाथ से दिला देंगे.
Hello, ma'am. How are you this morning?
How are you?
All good, ma'am. My script is ready, but just wanted to know which way to send.
Please join. Yes, second technical session. Please also. You have a mic here. Hello everybody. We have one more presenter here. Are you ready for that?
Yes.
Thank you so much.
Yeah.
That's immediate positive response is always welcome. Thank you so much.
Actually, they are asking for your permission.
Who's asking?
Everybody's asking.
Everybody's asking.
Everybody's seeing you as the most responsible person here. Very good son.
Where is it?
Where do you want me to send?
Sorry?
On for which email you want me to send?
M Sharma 9.
In Gmail.
Everybody, all the students, you are not realizing the importance of the session. Please take maximum advantage of the session. Do not spare them that easily. Right? Please talk to them. They will be outstanding mentors for all of you. Go ahead, talk to them, take them mentorship, take their ideas, take their suggestions. What they can give you, nobody else can give you. Right? Take the advantage of the session.
You shared?
Yeah.
You shared. Did you upload it on the link? The link must be shared with you. Did you upload it on the link?
PPT.
Can you WhatsApp me?
Yeah. Yeah, it's WhatsApp.
Yeah.
WhatsApp is easy.
I read. You're exactly to listen to you.
You have WhatsApp me? Yeah.
He is in auditorium to make the setup. Is there anyone else who would like to help him?
Sir is going there. Sir is going there. That's good. Sean is there.
Sean is there.
I'm going.
And Sir,
For a lot of sessions, you may start losing the track of who presents.
No, because I want everybody to be in the inaugural session. So it is good if we clear it right.
After WhatsApp, yeah.
But nobody's
Huh?
taking notes. Nobody's taking notes for who presents.
But you're taking signatures, no?
Formal, okay, but for the rest, I did nothing. It's other session.
But that's okay. But that's okay.
So formal, I took it too. What afterwards?
Hello?
Because
Hello?
it's actually used for.
हाँ
Notes.
मैंने बोल
Now getting tables from other.
मैं अच्छा मैं कर तो रही हूँ लेकिन मेरे को इंडिया ऑफिस से लेना पड़ रहा है ना और ये मैं एजेंडा ऐसा मेरे पास शेड्यूल है शेड्यूल दे दूँ क्या आपको हाँ 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 वो दे ठीक है ठीक है ठीक है सेशन तो मेरे को उठना बड़ा मुश्किल हो रहा है सेशन चल रहा है ना अभी तो मैं करती हूँ सुनते हैं रुको 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 करवाती हूँ हाँ करते ठीक ठीक You can take the mic. Hey.
Good afternoon, everyone. I'm Srinivas. Today, I want to present you the zero trust in the corporate network. I'm gonna ask a quick question, do you ever think that thousands of devices can be connected to a network can be a zero trust or no. I would like to thank you for this opportunity presenting over here. The whole research or the framework is like, doing a zero trust in the network, like using all open source, like a free radius and the PostgreSQL. And this proposal, whatever we are doing today, it's been like, tested in the production environment across across like, thousands of devices. And it's like, it's been configured in a main retail environment, and we have a production results here. My name is Srinivas. I'm a staff system infrastructure engineer. I've been working in this field like, more than 12 years. I worked as a systems engineer, and, I'm a cloud module DevOps engineer. And I've been, my core area is like, security and compliance. And, I worked across enterprise migrations, like, migrating the servers, like, thousands of servers in the live without downtime from one operating system to the other operating system. These are my like, four core areas, like, infrastructure modernization. Now it's like we in the olden days, we used to use the hardware servers and all that stuff, like, modernizing them to the cloud, and, creating a automation and pipelines. And it's like, making sure those pipelines are secure and compliance. And, I worked on like, server migrations. This is my core area. Now, the problem is like, if you're already aware of it, there is an attack to the 2013 in the Target stores. Like, the 40 millions of customers' data being stolen from the Target. This is happened because of a vulnerability in the network. Somebody entered, because there is a company like a HVAC company, with their credentials, somebody entered into the Target network and they stolen the entire 40 million of customers data. And a similar way, in 2021, there is like, Colon Pipeline Company, which provides a gas to the entire East America. That's been affected because of the vulnerability inside a company, and somebody entered into the company, and, they just stolen the data, customer data. And recently, if you know that there is a one vulnerability introduced into the Linux, like, if you have an access to a server locally with any privilege, you can simply switch into a root privilege user and you can do it. These kind of vulnerabilities are happening. Then how we can able to, like, now the perimeter is never been a issue here, because now it's like people are working from home, and, most of the applications are hosted in the cloud, and that's the reason perimeter is not a constraint over here. Then how you can make this thing as a zero trust, right? Because you have to trust someone who is entering into your network. How we can able to do it? Because now it's like you have IoT devices, like, hundreds of IoT devices. How are you going to do it? Like, there are like, regulatory moderates to prevent these kind of activities. These, like, today I want to present without any, like, you're signing to some contract, like, some vendor with $1 million. You don't, without doing that, with simple open source, how you can able to make this happen. See, these are the 5 components in this framework. Our framework implements the zero trust across these 5 layers. Device connects to the managed switches at the access point. The switch sends a MAC authentication, bypass the request. No endpoint software required. It's a free radius. It's an open source, and it connects to the PostgreSQL via a single SQL call. And it returns an access decision, whether it can be allowed or rejected, or this can be done through a simple SQL command. The switch immediately enforces the VLAN assignment. The critical design insight is the single policy engine. There is no distributed policies, or like, no per switch caching or anything. It's a simple 5-layer architecture, like, device endpoint, network and post and, radius. Suppose, just consider like, I'm in a retail store. Somebody wants to connect to my network. They're just going to connect their laptop into a switch, then it won't provide the network immediately. It just goes to the free radius, and it will ask, okay, I got a connection. Do I assign an IP address or not? Then the free radius will connect to the PostgreSQL. It make a query and it will check the database, whether the MAC address of this device is available in my database or not. If it is available, do I need to allow it or do I need to reject it? That way, the PostgreSQL command and everything will be monitored using a dashboard. Either it is a rejection or it is accepted. It's been sent it to the dashboard. This is the 5 layers architecture, and these are the 5 chances, like, how the device can be done. The first thing is authorized devices. Suppose in the intranet, we always divide into a VLAN. The point of sale has PCI data, like, customer data. That's a reason we always separate that point of sale into a different VLAN. And there are, like, friend stores, some kind of, like, we will separate them into a different VLAN. Now, the first scenario is your device is authorized because I added your MAC address into the my database saying that you can accept this MAC. Then it's a straightforward thing, right? That device will get authorized. And the second scenario is I want to block the specific MAC addresses. That would be my second scenario. Then if somebody wants to, like, connect, it's an unauthorized device. Then how it's going to work is it's going to be put it in a quarantine. Like, there will be a UI kind of thing or like a dashboard thing. There, the device will sit there. Somebody has to monitor that and they have to allow it manually. Okay, this MAC address is known to me. I want to allow that MAC address into my network. Then somebody has to approve it. Then once that is approved, that will go to the authorized device stage. And the second thing is somebody want to, make the spoofing of the MAC, like, they want to modify the MAC and they want to enter into the network. That's our, like, fourth scenario. In that case, that's been directly rejected and an alert been sent it to us saying that, okay, somebody trying to do the MAC spoofing. Then last thing is, like, we always audit every request and, it's been, like, audited. Now, these are not, like, I'm not talking this architecture like as a theory or something. These are all production ready things. It's been tested across the 10,000 retail environment where, like, this been implemented. It's like your response is within less than 200 milliseconds, and the accuracy is 19.99%. Now, you might have asked me, right? The radius, whatever I'm saying, right, or the open radius is installed or my SQL is installed locally to the retail location. Suppose what's going to happen, like, my local instance went down. The first thing is we have the scalability, like, replica sets. If one replica went down, you're going to have the other replica. And we have a fallback mechanism. If suppose the local environment is down, still the devices will connect to a central database where it is hosted in the cloud. Like, in the central, maybe each and every retail location MAC may not be available, but the overall MAC, suppose we aware of, like, some kind of known MACs, everything is centralized and added into the central database. That's how, if the local database went down or local radius is went down, the device try to connect to the central and it will try to get the authenticated. That's where you have a fallback mechanism. That's a reason I said, like, it's a 99.9% of chance there is, like, it will be, and the one good thing for here is it's 100% audit compliance. Like, every request been audited and it's been stored and somewhere, like, and it's like you can define how many days of data can be stored and archive it. These are the five compliances, right? Which are like shows the regular grade. This is not just a good idea. A key claim for this paper is that compliance is structured properly for this architecture, not configuration option. Because usually in the real-time world, there are like two categories, right? Somebody define their own policies and they're going to say that we are following the securities policies. But somebody enforce the actual policies and make sure that we are following it. This architecture comes into the second layer, second option. Like, these are these are like, core security principles aligned in this architecture. What is the case study? Actually, it's like I want to present a case study over here. Suppose like, you consider like you have 340 retail locations and there are like, 12,000 devices. The entire thing we design into three things. From week 1 to 4, the infrastructure setup. Like, installing a PostgreSQL, either you can install it as a container or you can orchestrate this into the Kubernetes orchestration, and you need to install the Postgres and the Radius, like, two free Radius containers. Now, here, the second thing is you need to implement this MAC-based rollout to the switches on 801.x security layer, like, to use this mechanism. And then it's like then from next time we implemented this audit streaming and everything. In this architecture, you have two options. You can put it like learning mode and you can put it as an enforced mode. Suppose you don't want to restrict any kind of thing into the organization, you want to allow it, then you have an option that changes configuration, make this Radius as a learning mode. In the learning mode, what the system will does is it's gonna audit each and every request and it will be kept in the database. Then later, like why you needed a learning mode is you have to understand before enforcing it, you have to understand what are your regular MAC addresses you need to allow. That's been done using a learning mode. Once that is done, you're gonna enforce it. When you are enforcing it, you're going to review all the MAC addresses you got in the learning mode, and you will make sure that's been added into the database as an accepted. Once you enforced it, then now on, whatever the new MAC address comes into the system will be audited and somebody needs to approve it. Otherwise, those will get rejected and a network IP assignment is not done. These are the 6 takeaways in this session. It's like, it's an open source. There is no need of like, engagement with any external vendors. Both free Radius and Postgres is open source. And every device is like, verified for each and every connectivity. And, it's a single policy element. There is no distributed states are configured. It's a fail-safe architecture. As I explained you, it has like if the local instance went bad, you always have the central environment to assign and check these policies. And it's a structural compliance one, and it is verified. The most effective thing is it is verified across the 10,000s of retail locations, and it's a proved thing. Thank you.
I have a question.
Okay.
So where do you implement AI in this entire system? I mean, it's just a futuristic way of asking this question, right? So you have this architecture, like a 5-layer architecture. Where and how do you implement an AI artificial intelligence?
Okay, now it's like, for the Docker containers, recently in the latest release, they released the agents in the Docker. By syncing the Docker, you can clearly, whatever the audit logs you are doing, right? You can give that audit logs to the agent. It can process it, and simply with like, if you ask it, they're like, so and so, how many devices got rejected? are like, accepted. Then AI can give you simply how many devices is activated, like, entire kind of like, end-to-end report to you.
Okay. What type of observability tool you usually use for your purpose?
Actually, it's like, there are like two ways. One thing, whatever the audit logs we are coming, we will send it to the Splunk. And in the Splunk, you can put the dashboards out of it and you can create create the alerts. That's the one way. The other way is there is a elk management, Elasticsearch. You're gonna send these logs to the elk, and in the elk, like Elastic process them, and you can create the like alert set. In our environment, what we also implemented is, rather than somebody going in and checking the alerts, we created a mechanism. We will process this alerts and we're gonna keep a threshold value for this. If there is a threshold, right, immediately a service request will be opened and it is sent to the support engineers. Like you don't need like support, because the main motive behind this is the retail location, the people who are working over there, they're like less technical. They're not aware of this technical things or something, right? That's where this the thing we automated is, no one need to open any ticket manually. It's like it just check the audit, our support group gonna call to the stores and they're gonna validate it. Man, I got this ticket. Is something is happening? Because this kind of thing, we not only for this thing, we implemented for all other stuff too.
Okay. What's the SLA you usually want to maintain?
Oh, for the priority one,
Yeah.
like in a 1 hour. Yeah. Anyone has any questions? Thank you.
Yeah, finally.
You're in charge, right? So, you're first. Jerry, and Andrew. That's very cool.
This is my paper, AIMS, an agentic AI-powered incident management suite. It has been built on Oracle Apex for enterprise operational management resilience. Our paper is co-authored by Ranganath Nangineni. He's unable to come here today, but I'll be presenting the paper and our findings. So, all right. The next 15 minutes, we start with the crisis in the enterprise incident management. Then we move through the AIMS architecture, 5 AI models, the agentic AI workflows, and the performance numbers, the results and performance numbers. We close with limitations, future scope, and our key takeaways as part of our AIMS framework. Next, I would like to ask a question to all the students here. Can you take a guess how much it would cost an enterprise, a mid-size enterprise, when their critical infrastructure is down? Okay, that's a good guess. So as per the Gartner report post-COVID in 2022, the answer for the downtime cost for mid-sized enterprises, we're not talking about Microsofts and ServiceNows and Netflixes of the world, but a mid-sized enterprise, the cost is $5,600 per minute, not hour, per minute. And yet 67% of incidences will take more than, it will take more than 1 hour, even though it's a known issue, the resources are aligned, and they're ready to fix an issue. They're on top of it, but it will take at least 1 hour for them to fix a known issue, known incident. And the worst part of the incident management in the current enterprise systems is ITSMs is 40% of the incidents simply reoccur. Same issue, same error, different week, different day. So, and this is not because of the knowledge gap or the resource constraints. It's just that the tools are not integrated properly, and there is we found that technically we found there are four structural gaps. The first thing, the very foremost thing is the incident management is mostly manual and reactive. There is no proactive ITSM, efficiently proactive ITSM designed yet at the enterprise level. And there is no persistent knowledge fabric across the teams, across different LOBs, or we call it lines of business within an organization. And the tools remain fragmented. So every team has their own knowledge base, everything has their own known errors or expertise, but they are and their own tools. But the tools are fragmented. They don't have a unified orchestration layer. And the teams lose up to 10 to 12 minutes in the very beginning of the incident, just to know that there is an incident triggered, the incident has occurred, and what is the right team, what was the incident about. So it will take at least 10 to 20 minutes just to get that idea about, okay, this is the incident and so person worked on that earlier. We call that as coordination tax. And AIMS is designed to eliminate all the four of these structural gaps. And move on to my next slide, which is literature review and research gap. There is a significant prior work done for agentic AI operations, agentic AI framework, LLM-based incident resolution. Microsoft did good work on that, and knowledge graphs. But if we notice the research gap column there, no prior work integrates all of these tools within production enterprise workflow. And Microsoft's ICSE 2023 study achieved 45% improvement using LLMs. 45% is great, but it is still in isolation, not connected to an ITSM pipeline. And Noida brought knowledge graphs to incident management. So this is one of the first enterprise organization which got knowledge graphs connected to incident management, but without LLM RAG integration. And while Oracle Apex capabilities with LLM has been widely published, documented, and used, there is no clear demonstration of Apex workflows used for agentic AI incident management systems. And it has, and there has not been a system that I am aware of, or my literature review, I could not find, or we could not find at least one framework which is built on low-code platform. So AIMS, we targeted to fill all these gaps as part of the AIMS framework that we have developed. So the AIMS system architecture, it has mainly 4 layers, and you can see the complete data flow in the orchestrated diagram, in the architecture diagram on the right side. Okay, on the right side there. And at the foundation, we have data sources. So we have outage tracker data source, checkout tracker, known errors database, and SharePoint root cause analysis documents, which has been stored away in the SharePoint servers. So these feed into the Oracle Apex workflow orchestration layer. The central nerve, which is the central nervous system, which is considered as central nervous system for our AIMS framework. It routes every incident through a defined sequence of automated AI-assisted or human approval steps. The third layer is 4 AI agents that we have developed as part of this AIMS framework. We will go in detail about those agents in the upcoming slides. And the top layer is a feedback layer. And the top layer is a feedback loop where every resolved incident enriches the knowledge base and reindexes the vectors in Oracle 23 AI database and the edges in the Neo4j knowledge graph. The system continuously gets smarter with every incident it processes. That is the whole idea of the AIMS architecture here. Moving on to the next slide, which is AI agents. So we have 4 modules, as I was telling in the architecture diagram earlier. So the first module is an intelligent incident assistant. It acts before a human even opens the incident, like the ticket that was created that some system is down. So it performs a vector search over the known error database that we have as part of our data source. It reads all the root cause analysis documents which has been saved in the SharePoint, which is relevant to each incident that has occurred earlier within the enterprise. And RCA documents using OCI language semantic matching. That's the name of the service. Using OCI language semantic matching, assembling a RAG prop and deliver a structured resolution recommendation. So the first module, it will go through the known error database, root cause analysis documents, and uses OCI language interpreter and the semantic search layer. And it will traverse through all the known errors and also using the vector search on the Oracle 23 AI. And we also have the knowledge graph that we will go over in the next slides. And it will deliver a structured resolution recommendation for the incident that has occurred. And in the second agent, which is our Teams triage bot, it eliminates the coordination tags that we spoke about earlier, right? So we have 10 to 20 minutes coordination tags. That 20 minutes coordination tags will be almost eliminated using this agent. So it creates using Microsoft Graph APIs, it automatically creates the teams based on the resolution that has been recommended in the first module, and the knowledge graph will recommend the resources and the teams which are relevant to all the stakeholders for this incident. So this M2 module. Okay, sir. Sure. Okay, sir. Let me sprint through in that case. Sure. So let me move on to the next module. So for the third module, we have a root cause analysis document summarizer. This agent will go through all the incidents and then comes up with a root cause analysis document that will be approved by the expert. And this fourth agent is our main meat of our framework, which is knowledge graph, where AIMS differentiate more sharply from pure vector search approaches. So we have 6 node types and 10 relationship types based on the Neo4j. Based on incident arrives, when an incident arrives, the graph will traverse through these known errors and then finds all the stakeholders based on the knowledge graph we have. This is the fourth module. And moving on to the next slide, which is 8-step agentic workflow. This is as I said, this is the central nervous system of our AIMS framework. So the steps 1, 7, 8 are all automated. Steps 2 and 3 are AI driven, which is MI, module 1 analysis and team flow creation. Step 4 is a human expert review gate, a critical trust checkpoint, which is step 4. And step 6 is resolution root cause analysis, which is a human AI collaboration. And step 5 is capturing insights automatically. Okay, so let's sprint through them quickly. Okay, the results here are very great. Actually, we got these results after 6 months of our framework deployment. So the mean time to resolve goes down from 55 minutes in traditional ITSM to just 32 minutes in the first phase, which is a modules, and it came down to 18 minutes after our knowledge graph integration. So that is a 67% reduction. And we have 87% improvement in the root cause analysis documentation, simply by leveraging the LLMs. And also we have 80% knowledge graph reuse for the full deployment. And recurring incidents dropped from 40% to 12%. And this is where the enterprise leadership was really, really happy that it dropped from 40% to 12%. And the bar charts here confirm these gains across every metric: MTTR, mean time to triage, mean time to investigate, and also recurring incident rate, and at each deployment. So we can see meaningful development at each phase, at each development. All right, and the limitations and the future direction is, the research here is about only 6 months operational data. So it has been 6 months after fully deployed, it's been only 6 months. So we don't have a full annual life cycle of the incidents. So whatever findings we have, results, it's about 6 months data. So it could get better for a full annual cycle, or it might get worse initially. It might take a dip. So that is one of the limitations. And also the OCIs, there are other limitations, but in the interest of time, the last major limitation is it would cost at least like around $1,500 to $2,000 per month to an organization. But this is just $2,000 per month, but per minute it is $5,600. So the benefit is so the risk reward is much higher. And the future side, we have M5 module that we are planning to automate proactive prevention of an incident. And we have federated knowledge graph so that we can share the knowledge and share these findings across different organizations without sharing the organizational sensitive data. And the last one is about eliminating the external vector database dependency by switching to Oracle 23 AI database consolidation. So the final, so the conclusion part, so we went over all of that. The another important point that I missed to mention was our framework is platform agnostic. So though it says the tool is built on Oracle FX or the database Oracle 23, but it is platform agnostic. As long as the tools or the platforms has REST APIs, we are going to use that. So we can, it's like a plug and play. If there is a REST API, it's like we have a HTML port. We can plug in names and then we can start using that framework for better incident management crisis response for an organization. And okay, these are our main references. So some of the selected main references are Microsoft, Moria, and Oracle documentation. And with that, I'm done. I would like to answer any questions if there are any. Sure, sir.
The speaker is 190. 190. 190. Next is 190.
Oh, sorry, it's in the mailing.
170.
Democratizing cloud. All right. Good afternoon again. I'm again Ashraf Syed. I'm still working for Virginia Department of Health. I did not change my position yet. My next paper is about democratizing cloud management in a self-service Oracle FX portal for adaptive OCI scheduling and cost optimization. Again, this is co-authored with my colleague Ranganath Nangineni. And here is our roadmap for actually next 10 minutes, not 15 minutes. So we open with the cloud management gap, then move through the system architecture, code components, adaptive scheduling engine, and the results. We can quickly go over the comparative analysis, future directions, and then conclude. So Oracle's own benchmark shows that 30 to 40% of the enterprise cloud invoice cost is spent only on instances that are sitting idle, which is like non-prod instances, nobody is working, no API call, not even an automated call. This instance is up and running and it is costing the enterprise. So that cost is up to 30%, 30 to 40%. So starting with an OCI interface, OCI instance through the console takes business under 12 minutes, navigating through the nested hierarchies, compartments, and IAM policies. So this is not the failure of the person who is the admin, or it is purely because the way the tool is designed, and it is designed for the right reasons like the security, scalability, and maintainability, modularity. For all those right reasons, the tool is designed that way. But it has this, the side effect is it is taking. And the root cause is, as I said, was OCI tools are not insufficient. They are designed mostly for the cloud engineers. But most of the business users who in the enterprises sometimes are, or most of the times are the decision makers, whether their instance has to be up and running or they want to just shut it down for this weekend. So, but they don't have any access to manage or maintain these OCI instances. And that is what that is where our self-service OCI portal is coming into picture. And we want to look into all these gaps. Okay. So we want to close these 4 gaps that is showing on the screen. And the next thing is about the system architecture. So OCI self-service, it is built on 4 layers. The first layer is the OCI instances at the base itself, and then we have the REST API layers where we can operate the lifecycle under the lifecycle operations programmatically, and then the third layer is where the core of the system is, which is again a FX 24.2 on autonomous database in OCI. And where our self-service package is built on, and it encapsulates all the lifecycle logic, and also the DBMS scheduler orchestration job runs. And this also handles the role-based access framework. And the additional cost for this module to build is, this module to run on the autonomous database is nearly 0 because FX is part of the autonomous database. And the top layer, user interaction layer, is where it has this reports, dashboards, and scheduler management, adaptive scheduling. And we also have embedded Gen AI chatbot built into the system. And the core components here is, we have 4 core components. Live FX collection, which is populating using REST APIs in the real time, which is handling all the scheduling, holds, executions. And a complete audit trail is built in within the epic selections. And the 8-role hierarchy, we have OCI admin at the top, just a view only role at the bottom. And we have developed the self-service package, which is encapsulates through all the lifecycle operations, which parses the OSIT string to route requests correctly. Every outcome is logged, audited, and presented in the AI UI layer. And the next Gen AI chatbot is embedded within Apex. So users are allowed to query through the servers or instances that they have access to or they are responsible for. On the next slide, we have adaptive scheduling engine. This is where OCR self-service differentiates from a simple cron job. The DBMS scheduler job fires every 10 minutes, evaluates through the 4 conditions, which is like whether it is the instance is scheduled right now, are there any holds on the schedule? Is it a public holiday, or the teams or all the team members are available? Is it a non-working day or a working day? And we have also a HCM integration. If the HCM integration fails back, we have a strategical fallback table as well. So administrators can use this to place holds for special circumstances, holiday holds. With many to one relationship, allow multiple non-overlapping holds, for instance. The result is a system that understands our organizational calendar, your team's sleep patterns, and your business expectations. So the workflow diagram on the right-hand side shows all those steps. Next, we have results. So the deployment is over, we have covered only 44 non-prod instances over 3 OCI regions, which is US Ashburn, Phoenix, and European Union Frankfurt area. And before every deployment, the instances used to run 24/7, but after deployment, which is after 8 months, right, as of now, it is 10 months, I think, but this paper is about 8 months. The system is adopted. These are all the findings. We got 32% less cost, which is saving up $12,000 per month, and annually it is up to $150K, which is the additional expense that has been saved for an organization. And the weekend incidents came down, and this you can clearly see through the graph here. All the metrics are showing improvement. And I would, in the interest of time, I'll skip the comparative analysis, but one point is this, our tool is not a replacement to an existing OCI tools. It is just a complementary tool where business users also can leverage OCI cost saving experience. And in the future directions, we wanted to expand our framework for all the other OCI instances and also across different organizations, different tenancies using federated model. And also we want to leverage machine learning and dynamic auto scaling. And to conclude, the self-service is a complementary, not a replacement to OCI tools, and we have more than about $150,000 annualized saving projected, and as of now, the monthly saving is more than $12,360. Right, with that, I think I'm done, and I'm happy to take any questions if any. Any question? Any question? How many models need compared, and what is the? So we have used across 44 instances, 44 instances, 12 OCIs, different types of instances. We have OS model, OICS, TPCS, and we did not touch the virtual machines and other parts because we are still in the phase of the. Any future aspects which you have covered in your paper? Yes, sir. We wanted to obviously we want to include AI, leverage AI as well, and also machine learning model for we have a machine learning model that we're working on. We can use also, we are planning to use data science model as well to come up with better predictions for our scheduling tool. Okay. Next presentation.
That's the Google Drive. What is the 171 sensor piece. Minimize this. Stop sharing. This one is getting. Good up. Good afternoon, everyone. My name is Suresh. I'm the author of the paper Wearable Sensor Fusion for IoT Healthcare Applications. Thanks for giving me the opportunity to present my paper. Basically, my research is around collecting the multi-sensor data and have a better predictivity analysis around it. The novel about this paper was we were able to collect 4 sources of data from ECG, PPG, accelerometer, and a skin temperature as well. And we had a three modular approach where we first had collected data was fine, and then we provided computation on it. I'll briefly go through what we achieved as well during this experiment. We were able to reduce the cross-sector variations for about 31%, and 22% improved in the feature stability versus the individual collection of data. However, we were also able to increase the accuracy of heart ECG signal collected from 87.6 to 95.8%. So as you are aware, basically the IoT healthcare system, currently relies on single modular sensor approach, where a single sensor will pick the data and will be computed further. However, in this novel research, we try to combine, a bedside sensor along patient side, where you can take multiple sensor input and then try to refine it and give a better predictive analysis for the end user to make decisions. In here, we just for the test data, we had a sensor estimated, a patients of 10 to 15 BPM, and we used deep learning techniques called LSTMs to achieve high accuracy computably. And one of the exceptional thing about this research was we used TinyML computation as well, making the compute power as as minimum as possible. So the technical design goals basically move around. We will have a unified 3-tier fusion architecture combining signal, feature, and decision level processing. By doing this, we found out we achieved very good accuracy, especially for the detecting ECG signals for 95%. We were able to reduce the latency as well below 100 milliseconds, and total power consumption was also reduced around 18%. So briefly touch around the 3-tier pipeline we used. we used signal level processing, in which we would do a feature level integration, and then a decision matrix was built at the end. The ECG signals were about frequency 250 Hertz, for PPG or 250 Hertz as well, and cardiac IMU was kept as 100 Hertz. The temperature signal we counted around 1 Hertz for this data collection. So our future scope involves, having create an adaptive fusion weight learning driven by sequential user behavior patterns and activity profile. We were also planning to apply some federated learning integration techniques on, privacy preserving on the cybersecurity side. And one more data point we were able to explore is using the blood oxygen level forward. And these are my references. Thank you everyone.
Next presentation. You have three. The next one. The next is
9394, paper ID 394. Hi everyone. Again, I have another was a co-author of the other paper ID 394. The title that Decoding Semantic Interdependency in Secure Energy-Aware Smart Healthcare IoT Ecosystem, a mixed method study using MCDM approach. So to provide a little background, as you know, healthcare IoT is real-time, collecting real-time data, but immersely faces energy shortage and security and performance trade-off. Motivation behind this research was to create a balanced security, energy, and efficient, reliable system for critical life-saving systems. One of the research gap we noticed is separate treatment of factors. No system MCDM analysis has been done previously on interdependencies. So basically literature review more focused on the edge computing side to develop a lightweight cryptography solution to have better efficiency and security. However, there are persistent challenges in the industry, especially with latency. So we try to close this gap and address with this research how we can have better results. So we have proposed a three-stage mixed methodology approach: a thematic analysis, a D-metal, and TOPSIS approach. For literature, we will consider 10 factors, experts' input from the matrix. Techniques we use D-metal and for casualty, and TOPSIS for prioritization. Our results were very promising compared to the other literature review papers. We found out, data security has an F2 factor, the highest among the others, and the interoperability of F5 factors. The energy efficiency also was increased to 0.86. Yeah, and we were able to achieve a strong casual data security F2 factor and energy efficiency F1 interoperability factor. TOPSIS ranking, we had a 0.8% increase in data security and energy efficiency of 0.86, interoperability of 0.83. To briefly summarize the results, the data security has the highest closeness coefficients of 0.89. Well, we found few limitations of our existing system, especially around the security and energy core. Currently, this two-factor affects the latency and accuracy as the main trade-off. As the energy consumption improves, it increases with the getting a better latency. This aligns with our provided comprehensive interoperability map of healthcare IoT. So I would like to conclude that our system proposed had an excellent F2 score of data security and energy efficiency. However, there is implication around better system design for sustainable smart grid. We plan to extend this scope by real deployment in future and also implement fuzzy logic to the integration. Currently, our data set was a bit limited. We will try to increase further research going forward. These are the references. Thanks, everyone.
Have you compared your model with the other model? Because there are some traditional models.
Correct. For literature review, we did compare 10 different models as the closeness factor. We did few models did had a better closeness, performance in terms of energy consumption. However, our model lacks getting you less latency. Obviously, increases the computational power as well. So we will be addressing that in future.
Because nowadays, connection is a time.
Exactly. Yes. There is a hybrid approach to divide in a more nodal manner, and we're researching on towards that. How we can have more less consumption device built around having lower consumption, but have a custom is a model built on. Good afternoon, everyone. This is for the presentation for the paper ID 396. Its paper title is the Casual Structuring of Energy Efficient Edge Intelligence for IIoT Anomaly Detection, a multi-method decision modeling approach. So in my previous paper, this is more aligned with the same, extending our research to specifically targeting industrial IoTs for anomaly detection and using the previously leveraged method implementing in the newer application for IIoT. So to provide a background, industrial IoT system generates a massive sensor data, but it's the first form, high latency and bandwidth issue. Motivation was to enable a real-time energy-efficient anomaly detection at the edge to prevent operational failures and reduce cost. One of the research gaps we noticed is the lack of systematic multi-carrier comparison of edge AI methods, integrating a thematic analysis with MCDM for casual structuring. So the key studies revolves around, edge computing definitely helps reducing the latency. The model compression we used in this study is quantization, pruning, distillation, and TinyML. One of the gaps we noticed is, the fragmented signal technique focuses only on, the multimodal method that metal ISM and TOPSIS evaluation of energy accumulation. We try to, with this research, we try to address those, gaps. The methodology we proposed during this paper is, involves, yeah. Yeah. So the proposed four-stage framework identifies hybrid tiny ML approach, as I explained, which was lacking in our previous release. We try to extend it here. We build a system which is more energy efficient, has better high accuracy and low latency. It's up to briefly define the numbers. I'll just go through that. For TOPSIS ranking, we were able to find the hybrid tiny ML framework address the best solution for providing score of 0.891. Future scope, we want to explore it to a real deployment testing and implement the fuzzy logic to it. Currently, the data set, yes, we would like to expand our data set and ultimately build a custom data set for as well, and aim for a higher journal publication. Thank you.
Thank you. What's up? 186. It's on the drive, yeah. 186. Is this on?
Yeah. No, it's off.
Oh, you pressed it.
Yeah.
No, 186. It's on the there it is. Yeah, you can find an application. Awesome.
Good evening. Don't worry, we'll keep this quick. So I'm here on behalf of Kubrick Group. We're a consultancy based out of New York. Just want to talk to you guys a little bit about a paper we put out there based on our experience with a recent client. So if you look at the title, we're interested in presenting a paper about physically informed approaches to wastewater anomaly detection, everyone's favorite topic. So our goal was really to improve anomaly relevance by incorporating known system behavior. So with some of our client work out there, we've seen a lot of things where there's some real gaps in terms of how wastewater, specifically water companies, detect anomalies. So they're often struggling to differentiate between what's expected behavior, what's a true anomaly, and what's the actual causes of these issues. So we wanted to present an approach that would kind of bridge that gap a little bit. So brief introduction here. So water telemetry data is highly variable due to rainfall, pump activity, daily demand patterns. There's so many different things that go into it. You imagine the wastewater that runs through a town and how many different types of factors come into play there. So traditional anomaly detection methods often flag expected behavior as abnormal, and this is the gap that we were going after, because that really creates operational noise that if you're actually wanting to make an operational impact, that's something you need to avoid and you need to be able to see through to actually make a difference. And so that's kind of what we're going after here. In terms of literature review, most prior research again focused on statistical or machine learning detection directly on raw telemetry signals. So a key challenge identified across studies was limited interpretability as well as operational usefulness of alerts. Again, like I've been highlighting, just because something is abnormal doesn't necessarily mean it's deviating from what's expected or unexpected, especially in the world of wastewater. In terms of some methodology here, so in research design, the framework first models expected behavior using known system drivers and then detects unexplained residual deviations. Anomalies are further classified into wet weather and dry weather contexts just for operational interpretation. In terms of data collection, we used public Wessex water telemetry data over in the UK from 24 sewage pumping stations across 2022 and 2023. A lightweight physically informed model and a MAD Z-score residual detection approach were applied and compared against a raw flow baseline, just to give us an initial approach for how we were going to do this the first time. terms of some results here, so you can see on the projection screen that I'm clearly covering up, conditioning on rainfall and operational behavior significantly changed the anomaly distribution and reduced rainfall-driven alerts. Dry weather anomalies became more visible, making potentially actionable events easier to identify. In terms of what we're looking at here for the results analysis and the closing aspects of this, conditioning on rainfall, incorporating known system behavior improved anomaly interpretability and reduced known operational noise. Overall, physically informed conditioning provided a more practical and operationally useful approach to wastewater anomaly detection. But as alluded to earlier, how we approach this was very limited. We're only using a couple different signals for wastewater. And as I said earlier as well, there's so many different things that go into wastewater, let alone just natural effects, just the effects that we apply to in our daily lives is interacting with the sewage systems and the pump systems and the water that we aren't even aware of. And how do we actually take that into account and take all those signals out there and interpret them as true anomalies versus false anomalies, and something that a company who's actually trying to improve its efficiency, how do they actually take action on those as well? So in the future scope, we really look at just expanding out the telemetry signals, so we have a very limited set. So we want to make sure we're capturing everything that could affect pump and rain flow as well. So future work would really incorporate that, things like pressure, wet well telemetry, really improve operational context. And while we did start this paper with the intent of being kind of causal anomaly detection, we diverted away from that a little bit. So I think there's an opportunity there to actually drive into the basis of what's the actual causes related to these anomalies. And that would actually provide some real operational value for any type of wastewater company as well. So we'll close it off there with the beautiful references, which everyone can hopefully read and recite tonight. But yeah, that's it. Any burning questions? Thanks, guys. It's been wonderful.
Yeah. How's it look? Perfect. Yeah, I better see this on the front page. Yeah. Sure. Perfect. Thanks.
नहीं मेरे पास Good morning everyone. My name is Aishwarya Singh and I'm a third year student at Amity University, Noida, Uttar Pradesh, India. So it was start. Good morning everyone. My name is Aishwarya Singh and I'm a third year student at Amity University, Noida, Uttar Pradesh, India. Today I will be presenting our research paper titled Predicting Winter-Induced Disruption in London's Urban Road Network using Ensemble Classification and LSTM-based congestion forecasting. This work was done under the guidance of Professor Anand K. Jaiswal, sir. So let me start with the problem. London has a mild oceanic climate. It really experiences serious winters. Because of this, its roads are not built for ice or snow, and drivers are not used to freezing conditions either. So when winter does hit, even just 1 degree below zero or 1 centimeter of overnight snow, the entire road network system goes into distress. One accident leads to another, and disruption spreads across connected roads very quickly. The economic impact is significant. Delayed emergency services, business losses, and road closures follow every major winter event. The core problem is this: operators currently find out about accidents after they have already happened. There is no early warning system in place. We asked one question: can weather data alone predict 1 day in advance whether tomorrow will be a dangerous day on roads? And if yes, can it also estimate how congested the network will be? That is exactly what this research tries to solve. We used 5 years of winter data from Heathrow Airport and built two-part prediction system, one model for accident risk and one for congestion forecasting. Before building our system, we reviewed existing work in this area. As you can see in the table, several researchers have tackled related problems. Becker and others used statistical models on German crash data and found that weather effects on accidents are nonlinear. Abu Hassan and others found snow depth is better crash predictor. On the forecasting side, Zeng and others used CORM LSTM for traffic flow. However, this is the key gap. No prior work combines both accident risk classification and congestion forecasting together, especially for a city like London. Now, let me walk you through the methodology. We collected daily weather data from Heathrow, the standard London weather reference in transport research, covering 5 winters from 2019 to 2024. giving us 599 valid daily observations. The variables we used were mean temperature, precipitation, snow depth, humidity, and cloud cover. From these, we built a winter severity index, WSI, equals 0.4 times temperature deficit plus 0.4 times snow depth plus 0.2 times precipitation. Temperature and snow get equal weight because they directly cause icing. This diagram shows how the entire system is structured across 3 layers. Layer 1 is data acquisition. Layer 2 is feature engineering. Here we normalize all inputs, compute the WSI, build 5-day sliding windows for the LSTM. Layer 3 is the model core on the left. Random forest classifies accident risk and outputs a binary flag, safe or dangerous. On the right, LSTM takes the 5-day weather sequence and outputs a congestion index between 0 and 100. Both outputs then feed into a single decision support signal telling operators the winter risk level. The entire system needs nothing but weather data to run. Now let us look at the results. The table compares logistic regression, our baseline, with random forest. LR achieved 75% accuracy, which sounds reasonable, but look at the recall. It's only 0.12. That means it missed 431 and out of 489 dangerous days and labeled them all safe. In a real operational setting, that would mean no warning issued on 431 days. Now look at random forest with threshold 0.22, accuracy jumps to 94.1%, and that is 67% reduction in undetected dangerous days. This slide has two important validations. First, the ablation study. We asked, does the winter WSI actually add value, or is it redundant? Using raw features, it gave only 0.6 recall, and but combining both WSI and recall, it gave 0.71, the best result. Second, the stability table, we ran both models 3 times with different random seeds. As you can see, standard deviation is very small. And regarding feature importance, WSI ranked first across all 100 trees, followed by temperature deficit and precipitation. But on days with more than 2 centimeters of accumulation of snow, it became one of the strongest predictors. For congestion forecasting, the LSTM achieved an overall RMSE of 8.72. Now, the more important number is here, the moderate severity band, when WSI is between 0.20 and 0.55. Why does this matter? Because low severity days clearly need no action, and high severity days, extreme winter, are already obvious from any weather forecast. Now, let me explain why these results make sense. LR failed because ice risk is threshold driven, and temperature crossing 0 degrees flips roads condition entirely. A straight linear boundary cannot capture this. Random forest splits data recursively at 0.22, recall is 0.71 with precision of at 0.51. To summarize, we achieved both objectives on classification, random forest with threshold 0.22, cutting and reached 71% recall, 59% F1, 94.1% accuracy, cutting missed dangerous days from 431 to 142. On forecasting, the 5-day LSTM achieved RMSE of 8.72 with biggest improvement in moderate severity band, where operator decisions matter most. Looking ahead, the most immediate next step is replacing simulated traffic proxy with the real TFL operational data. The pipeline is already built for this. We also want to move from daily to sub-daily resolution, since TFL plans around intraday peaks, not daily averages. And here are the references that we have used. Thank you.
Any question? No question. When you have taken a random forest,
So random forest gives a better recall than all other techniques that we have used. That is why random forest is used for absolute.
what is the size of your data set?
It is 599 with missing data removed, because TFL, we have taken data of 5 winters from November to January for the London winter, and TFL gives data on a broader aspect, and it does not provide real-time data to public.
Anything you haven't covered in this paper and what is the futuristic work?
Yeah, as soon as CFL allows public to get the real data, we will try to integrate that into and work. Thank you.
Yeah, so it is 217 first. Hello. You start. So this is the research paper. I'm Dr. Navleen Kaur from MIT University, Noida. And the topic is central bank digital currencies. It is CBDC. CBDC is again one of a new concept. Pilot survey, it started in 2022. We already have Paytm. We already have number of wallets which are there in India. But still we are on the running stage, on a training stage when it comes to central bank digital currency. So you have an idea about what is CBDC? What is central bank digital currency? Any one of you? We have a 100 rupee note. We have a 500 rupee note. That 100 rupee note, 500 rupee note, you are going to have in your mobile phones, right? You're going to tap it, whatever amount you want to give, it will be deducted. That is CBDC. Now the question arises, what is the difference between CBDC and Paytm wallets? Paytm wallets or any other wallet, it runs through what? It runs through internet. Without internet, you cannot run that. But for CBDC, you don't require internet. Is it clear to you? So this research, it talks about the digital payments and it talks about central bank digital currency, which India has launched, which is also known as your digital rupee. And digital rupee, it was in year 2022, when the pilot survey it started, right? And this is how the digital rupee, it appears. Now, what was the research gap? Existing research largely focused on UPI. It focused on mobile wallets. It focused on digital banking. While CBDC adoption in India, it was not that much focused. So this was the reason the comparative analysis is made between both digital wallets and the central bank digital currency. So we're trying to understand how much the consumers are ready for the same. So for that matter, you can see here that this is how the CBDC is working. There was a pilot launch, then expanded pilot, then phase rollout, and now continuous improvement. So we are trying to improve it to the max. Now the question arises that if we bring CBDC, what are the challenges that would be faced? So these are the challenges that would be faced if we bring CBDC. And the challenges are, number one, everyone would have the currency in their mobile phones. What would the banks do? Bank would say that everything is there in the mobile. If you're not depositing in the bank, from where the bank is going to give the loan? Because the major motive of the bank is to give the loan to get the deposits. But the deposit is already with you because it is with you in all your mobile phones, not in the bank because bank is not involved in this. This is one of the challenges which is faced. The second is user adoption. How much users they're ready to adopt. then cyber security, UPI dominance, regulatory fine-tuning, technology testing. These are all the challenges which India is facing. Here our motive is to create the awareness among the people that you should enter into this new fintech, which is financial inclusion, and you should cover central bank digital currency, and it should be the part of your mobiles. Now, what were the findings? 50% respondent identified CBDC correctly. So 240 respondents were there. 50% they knew what CBDC is, but then there were only 16% who have ever used it. They had no idea about what it is. So at least you get an idea what exactly is central bank digital currency, right? And how this particular digital currency, it is going to be the future of India. And then apart from it, we have seen that what are the barriers? The barriers are cyber security, then privacy risk, and limited merchant acceptance. Number of times the merchants, they don't have that facility in India yet. So even if you want to pay and the merchant is not giving you the option, you will not be able to pay it. So we just have to work on the same. So this paper is all about it. Thank you so much. And the last which I'll cover, right? And the last which I'm going to cover is Level, and the last one is 172. 172. Absolutely. Now, this is again one of the paper by one of my very close colleagues in India, Dr. Noida Mahajan, along with the team. We have written this paper. So I am just presenting, just have a look. This is on circular supply chain management. Again, what is circular supply chain? Whenever you purchase anything from Amazon, what do? Do you absolutely right? Do you also return it? Absolutely. So what needs to be done to those return items with the help of AI? This is a research upon, which is on a circular supply chain. That is, you purchase from Amazon. Amazon is returning it to you. What you are going to do of that particular return? What Amazon is going to do of that particular return with the help of artificial intelligence? That is what is on a circular supply chain. Somebody orders and then someone returns. What are you going to do of that particular return, right? Now, in this case, the research objective is predict likely product returns. So what is done in this case? It is not a research which is done through a questionnaire, but it is a research which is done through synthetic data. And this synthetic data is of 480, the data is of 480 responses that we have received, but these responses, they are generated through artificial intelligence. That is what is known as synthetic data. So you can see here, 480 realistic supply chain scenarios where the customers, they purchase the product and then they return the product. So the framework is predict, optimize, and then execute. So the AI model which is used here is CLDIM. CLDIM is known as closed loop decision intelligence model. CL is closed loop and decision intelligence model. What it does, it integrates all the AI models together And those models such as XT Boost, Random Forest, which already Aishwarya was discussing, they take all the models together and then they see that what needs to be done with that product. Whether that product should be refurbished, whether that product should be disposed, or whether that product should be again sent to resale because it is 100% fine. So what were the results and analysis? Improved value recovery because the returns they were predicted. They reduced waste disposal, lower environmental impact, enhanced decision support, right? So the returns, they were really improved with the help of artificial intelligence. So this was the result. When the model which was used was baseline, it was 41.2 error which was there. When it was random forest, it was 21.7, XT Boost, it was 18.4. Better the AI models, more the integration, better are the results. So the conclusion is the proposed CLDIM framework demonstrate how AI can enable smart decision making in circular supply chains. So with the help of AI, the returns, they are also being improved, and this model would be applied in the future. And it can be applied to various sectors such as electronics, retail, automotive, and FMCG sector. That's all. Thank you so much. Thank you. Thank you. Lamana, you can just join.
Now, ready 322, right? Okay. Okay, better item 322. Now we can start.
Good morning, everyone. I'm Lavanya Alba. I'm a BTech CSE student at Amity University, Noida. I'm presenting my paper 322, IoT enabled real-time workplace safety risk classification using ensemble machine learning and shaft explainability. And it is supervised by Dr. Anand Kumar Jaiswal, sir. I wanted to start not with a definition, but with a story.
My father owns a factory. He manufactures electrical rickshaws. One evening, he called me and said, something happened today. One of our workers got hurt. When I asked him, he said that there were numerous reasons for it. So, first of all, the reason was noise. It was unbearably high. So high the workers couldn't tell if the grinding sound was from his own machine or from breaking down of another machine. So noise was so overwhelming that in a factory, 1 second of lost focus is enough, and that is exactly the problem this paper is about. According to ILO, 337 million workers are injured and 2.3 million die at workplaces every year. That's 4% of global GDP in losses, and the reason it keeps happening is because every system is highly reactive. Incident happens, investigation occurs, and then the corrective action is taken. So by the time the action is taken, harm is already done. So that's what my project solves here. We weren't the first one to think about this, but look at what already exists and where it falls short. So these are the few references, and in one reference by Hassan and Khalifa, there were good results, but working on past incidents and no real-time sensors and no explainability, whereas our project involves real-time sensors as well. And in the other ones also that was the case. In one, there was an ML model involved that was sharp, but we have used XGBoost that has less accuracy, but it is better with our kind of project. Back to my father's factory, imagine 9 sensors embedded around the floor and on the workers. What are they measuring? They are measuring CO2, temperature, noise, and time since the last inspection. So the CO2 is above 2000 ppm. A worker's ability to think and react starts degrading. And if the air quality index is much greater, like PM10, chemical pollutants from the machine, they also affect the worker's health. For example, the temperature is like 50 degrees Celsius. Error rates climb sharply. If the noise is above 85 decibel, the worker can't locate the source, cognitive load spikes, and the focus drops. And same with humidity, worker density, and days since last inspection is also important for detecting risks in worker safety. All this data feeds into 10,000 synthetic records calibrated against OSHA and NIOSH exposure limits. But only inside each training fold, this is critical. If you oversample before the split synthetic test samples, leak information from training data and accuracy, inflates artificially, we eliminated that entirely. Then 6 ML classifiers, SVM, logistic regression, XGBoost, live GBM, random forest, and decision tree were taken. And all these 5 stratified cross-validation results showed that XGBoost was not highly accurate, SVM was highly accurate, but XGBoost was the better one in this kind of project. And now for the results and analysis. Across cross-validation, SVM achieved the highest accuracy, as I told you, but XGBoost followed at 99.86%, and the decision tree was weakest at 99.01% with the highest variance. Classic instability of a single unpruned tree. You might ask why not deploy SVM, as I told you. That is exactly the right question, because in safety critical systems, accuracy alone is not enough. I'll show you why on the next slide. So XGBoost achieved 100% macro accuracy. Only 5 micro classifications out of 2000, but the number I want you to remember is 0. 0 high risk samples were ever predicted as low risk. SHAP tells us why CO2 ranked first at 0.689, air quality index at 0.682, temperature at 0.665. So basically CO2 is the most effective thing that harms workers' health. That tells you every sensor has a job and you cannot cut corners in deployment. So the main reason is why I chose XG Boost over SVM. So SHAP tree explainer computes exact Shapley values for XG Boost in polynomial time. For SVM, it's exponential, unable to scale. XG Boost supports incremental retraining as real factory data accumulates, and it outputs calibrated probabilities so a safety officer can set the alert threshold based on their site's specific risk tolerance. Compared to other models with no explainability and on limited sensors, our model delivers higher accuracy plus smooth pipeline, 6 model comparison and sharp attribution, and a deployable dashboard. So we also made a dashboard on Streamlit, and that's working currently right now. In summary, a complete proactive IoT ML pipeline for workplace safety risk classification. Three gaps were closed simultaneously: prospectivity, leak-free smooth, and sharp explainability. XG Boost deployed not for raw accuracy, but for practical reasons. The model never called a dangerous situation safe, which is the only failure that truly matters, and safety officers get not just a warning, but a sensor level reason that they can act on immediately. And I will also discuss the future scope. We are thinking of integrating a IoT wearable device that can be placed on your hand, and it detects a worker's heart rate and his CO2 breathing and heart rate sensor on the device that detects if that detects the fatigue of the worker, basically. Yes, that's it. Thank you so much. These are my references. Thank you.
How many models you have created? Compared, basically. So out of all the models, which one performs outperform the other model?
Actually, SVM performed better, but we chose XG for this model because it gave more practical decisions.
Okay.
Thank you.
Okay.
इसमें सर प्रेजेंट करना
ये है लाओ कौन सी है 271 डाउनलोड्स ये है 270 Good afternoon, everyone. I'm going to present paper, the topic, Enhancing Network Institution Detection System using honeypot-based instruction logger. Paper ID is 271. So my presentation is basically divided into 8 parts. First one is problem statement and motivation. What is the research objectives? Proposed hybrid IDS architecture. Then why we are using honeypot-based institution logger. Then is experimental setup, result analysis, conclusion, and the references. Let's quickly see the problem statement and the motivation. As you know that nowadays we are using online services, remote access services, cyber security threats are increasingly significantly increases. There are some institution detection systems which are fully effectively not applicable to all the systems because they are mainly rely on the predefined attack signatures. Such systems face major challenges in detecting new or unknown attacks, reducing false alarms and responding quickly to the threats. There are basically 3 main problems with the IDS. One is detection delay, another one is poor detection of unknown threats, and alerts, fatigue, and false positions. Now, what are the research objectives of this paper? Basically, there are 5-6 objectives. Reduce the institution detection delay, improve detection of unknown attacks, reduce false positives, improve real-time network monitoring, use honeypot to collect. This is a hybrid model. So I have integrated the traditional model with the honeypot. So that is basically the that is giving the better result as compared to the traditional model. And that is increasing overall IDS effectiveness and accuracy. Now let's see what is the proposed model, what is the hybrid model. That is divided into 4 steps. One is called packet capture phase, and second one is feature engineering. Third one is basically there are traditional method like signature rules, anomaly models, and behavior finite state machine. And then all these are combined to get the decision. That is your 4th phase is decision. And then in between there is a honeypot logger. So basically the packet capture allow the system to monitor the large scale network activity in the real life. Now the second phase is feature engineering phase. That is basically captured 42 important features, that is including protocol types, port types, transfer control protocols, payload entropy, timing information, failed logic attempts, and service interaction details. Basically these features are used to input the machine learning and behavior analysis model. Now the proposed model is basically, the 3rd phase is basically multi-paradigms classification phase. This system combines 3 major detection approaches. First one is signature based, that is your traditional method. This module basically detects already known attacks using predefined rule and signatures. And second one is anomaly detection. This model basically identify the abnormal network behavior using machine learning model. It is useful for detecting unknown and 0-day attacks. What is basically the 0-day attacks? Sometimes the software is there, but there are some person who is not able to not able to attack the attackers. They are not able to find the attackers, and that is the problem is not fixed up basically. So that is called 0-day attack. And then third one is the behavioral analysis. Behavior model basically they monitor the sequence of activity performed by the attackers. And then as you know, there is a FSM, that is finite state machine. So everyone know that there is a predefined sequence. If you're not following the sequence, then there are pattern is not match. So it will give you an error. So always follow the patterns. Now all these things will be collected together. And then there is a 4th step that is called response coordinate phase. In this phase, basically the outcome of all the 3 phases, all the 3rd phase like signature rules, anomaly models, and behavior finite state machine, we are using one equation, and there is all these three component will be combined together. Generally, there are some papers, the anomaly models having the weighted value is more, then we are getting a better results. Then S final is basically 0.35, so D value, that is signature value, and 0.4, and then anomaly values, and then 0.25, that's the behavior value. If its value is greater than 0.85, the traffic blocked automatically. If the score is between 0.65 to 0.85, then alerts sent to the analyst. And then if score is less than 0.65, then it considers normal telemetry. So based on this, we are taking the decision. Now, what is the role of honeypot logger? Basically, the honeypot logger is a fake system or service designed to attack attackers and record their activities. The proposed system illuminates services such as HTTP, Hypertext Transfer Protocol, 5 Transfer Protocol, Telnet, SMTP, the Simple Mail Transfer Protocol, MySQL. So when attackers interact with these services, the honeypot records login attempts, user names and passwords, command executed, request pattern, and session duration. So this information is correlated with the IDs alerts to improve the attacks detection accuracy. The honeypot remains isolated from the real protection networks to maintain the security. Now there is an experimental setup. Basically, I have used 59,800 training data sets, which includes 47,000 points that represents begin events, 2,800 points representing malwares, and 15 kinds of attacks. So this is a training and evaluation configuration for the experimental setup. And then the next is the result and analysis, detection effectiveness. The hybrid model, which I have proposed, that attains 97.8% overall accuracy detection as compared to the traditional model, and then 1.2% false positives. Malware delivery and web application generated the highest detection scores due to the signature-based techniques, abnormal behavior, and the presence of honeypots enhancing each others. So this is a result of the scenario-wise detection performance. And then the next one is comparison with the existing IDs. Generally, there are traditional IDs like Suricata, Snort, and then Jig based on the similar condition and then circumstances. In the similar condition and circumstances, all these IDs are already there, and then proposed model is outperformed than all these models as compared to this. So this is the proposed hybrid model that is using the honeypot. It is getting the accuracy between 97.8, and then the failure FPR is 1.2. Now see the third one, false positive root cause analysis. The researchers analyzed the reason behind the false positives, legitimate admin scans, backup activities, and port knocking the internal process. So here basically we are getting a false positive reduced from 1.2 to 0.73. Right. So the conclusion of this paper is basically high detection accuracy of 97.8%, strong null attempt detection of 94.2%, and very low false positives, basically reduces from 1.2 to 0.73. So these are some references. Thank you.
टॉपिक बोलो फिर नाम बोल सकते हैं कि प्रेजेंटर प्रेजेंटर को फॉलोइंग ये लिख लो सर Good evening, everybody. The topic for today's research paper is predicting firm-specific risk in emerging markets via localized sentiment and industrial activity gaps, a hybrid ML approach. And the presenter for the same are me, Vidushi Chandra, Naina Sharma, Rishabh Kushwaha, Dr. Namita Saha, Dr. Smritananda, Simran Siddiqui. Introduction, problem statement. Let me begin with the problem we are trying to solve. Predicting firm-specific in emerging markets is especially difficult because these markets often face high volatility, delayed financial reporting, and lower transparency. Traditional financial models mostly rely on quarterly reports and structured accounting indicators such as profitability, leverage, and liquidity. The limitation is that by the time these reports become available, the risk may already have materialized. For example, a company may publicly appear financially stable while operational disruptions are already happening internally. So the core question for our research is, can we detect firm-specific risk earlier using alternative real-world signals? Instead of waiting for financial statements to address this, we propose the KLDI framework. Research gap and objectives. When we reviewed prior literature, we observed that most existing studies focus on isolated data sources. Some use only financial indicators, some rely only on sentiment analysis from news or social media, others use satellite imagery independently. However, very few studies integrate all these perspectives into one unified predictive framework. This creates a research gap, and the objectives were as follows. First, to develop a hybrid machine learning framework. Second, to improve early decision of firm level risk. Third, to reduce false positive alerts. And finally, to improve predictive performance compared to traditional models. KLDI framework architecture. This slide explains the architecture of our framework. We use three major input streams. First is structured financial data, such as profitability, liquidity, and leverage. Second is linguistic data from regional news, worker review portals, and supplier forums. Third is kinetic activity data captured to SAR satellite imagery. The linguistic stream is processed using multilingual BERT or MBERT, which allows analysis of local language sentiments. The kinetic stream captures physical operational signals such as thermal activity and logistics movement. These signals are then integrated using XGBoost to detect divergence patterns. The final output is the KLDI risk score. Methodology. Now let me explain the methodology step by step. Step 1 is collecting structured financial indicators. These include traditional performance. Step 2 is linguistic analysis. Here, multilingual NLP processes local discussions, worker reviews, and supplier-related conversations.
Step 2 is linguistic analysis. Here, multilingual NLP processes local discussions, worker reviews, and supply-related conversations. This helps identify early operational stress indicators like payment delays or labor concerns. Step 3 is kinetic monitoring. We use synthetic aperture radar imagery because it works even under cloud cover. This helps monitor factory activity, logistic movements, and thermal output. Finally, step 4 is machine learning integration. XGBoost identifies abnormal divergence pattern between sentiment and operational activity. KLDI formula. This is the mathematical representation of KLDI. In simple terms, the formula calculates the difference between linguistic sentiment and kinetic activity signals. A larger difference means a larger divergence between public narrative and actual operational behavior. This divergence is then adjusted by a transparency weight. The transparency weight increases the risk sensitivity when companies delay reporting or disclosures. So mathematically, higher divergence equals higher predicted firm risk. Conclusion and future scope. To conclude, traditional financial models alone are no longer sufficient for timely firm risk predictions in emerging markets. Our hybrid KLDI framework demonstrates that integrating alternative data improves prediction significantly. By combining financial indicators, multilingual sentiment analysis, and satellite kinetic monitoring, we achieve higher accuracy, earlier detection, and lower false positive alerts. This framework provides a more realistic and proactive risk assessment approach. A future scope. Future extensions may include integrating climate risk indicators, real-time supply chain intelligence, and expansion across multiple countries. Real-time AI development could further improve practical adoption. Thank you.
इसका सर के मेरे सर पे नहीं है Greetings, everyone. My name is Shubhan Shah from Department of Computer Science and Engineering at MIT School of Engineering Technology, Noida. Today I'm presenting my work titled A Biometric Voice Security System Enhanced with Emotional State Recognition. This paper was developed as a part of our research into making voice-based security smarter, more resilient, and more human. Now I'd like to take the next few minutes to walk you through the problem we've set to solve, the system we built, and what our experience showed us. Now the question that we probably ask ourselves every day is that how many passwords do we have? Like we have pins and passwords and also some sorts of I keys and everything. But then these days we just write it down in notepads and diaries. But then that's the traditional authentication that we do. And it has its own weakness. It can be vulnerability to hackers or even someone finding it in the desk. And you never know who carries it. But now the voice biometrics, it changes everything. The voice is as unique as your fingerprint. It cannot be forgotten. It doesn't require any special hardware, and it works in real time. That's why voice authentication is already being used in banking, and I'm sure you all are facing it when you do the transaction via the debit cards and so. But the problem that nobody was solving is that with our voices changes when our emotions are not the same. When we record our voice, we are happy or sad, and when the banking starts for verification, they are unable to verify it because they can't know what our emotion is. And especially when you're stressed in some work or in scared in emergency, it doesn't verify, and hence you're locked out from your own banking account and many more. So now we are treating this emotion as a noise and that error in the system instead of an information about the user. So the gap that we now research addresses is that what if instead of fighting emotion, we understood it? Now within this last few years, a lot of scientists have tried doing it and some have achieved the success, but they would fail at the emotion state. Be it all these years, they've failed. So how did we build this? Think of a system as a multi-stage security checkpoint, like an airport for your voice. The first stage is pre-processing, where a user speaks into the microphone, the audio is cleaned up, the silence is trimmed, volume is normalized, and noise artifacts are removed. Think of this as ironing the shirt before the interview. It makes everything downstream more accurate. The second stage is feature extraction. We convert the audio into what are called MFCOs, male-frequency celestial coefficients. These are a set of 40 numbers that describe what your voice sounds like to a human ear. Think of it as a recipe card for your voice. We extract this recipe from very small slice of time in this recording. The third stage is voice biometric verification, followed by the pass-face check, and only after both of these gates pass does the fifth stage activate, emotion recognition. A CNN LSTM model analyzes the same audio and classifies your emotional state across 8 categories: angry, calm, disgust, fear, happy, neutral, sad, and surprise. The CNN looks at local patterns in the sound. The LSTM tracks and how those patterns evolve over time. Together they can say, this person sounds calm or this person sounds anxious. Now, as you can see, for the voice authentication, we have achieved an average accuracy of approximately 93% with false acceptance rate of 3 to 5% and a false rejection rate of 5 to 8%. The equal error rate, the standard industry benchmark, came into an approximately 6%. Those numbers reflect a system that is both secure against imposters and fair to genuine users. The passphrase verification layer achieved 97% accuracy combined, and the unauthorized access rate was under 3%. Average response time was 4 to 5 seconds. For emotion recognition, our CNN LSTM model achieved a validation across of 61% across 8 emotion classes. Now to address that number directly. On the surface, 61% might sound moderate, but context matters. Recognizing 8 distinct emotions from voice alone in a speaker-independent setting is a genuinely hard problem. The state of the art in similar constraint dataset studies sits in this same range, and what our confusion matrix reveals is actually quite calm, insightful. So what do these results tell us taken together? The most important insight is architectural. By separating authentication from emotion, the biometric module acts as a gate, It ensures that the emotion model only runs on verified users. This means any imperfections in emotion recognition never become a security liability. The system is robust by design. We also observed overfitting in the emotional model, where training accuracy was 99.91%, but validation accuracy was 61.45%. This is known as challenge in speech emotion recognition, driven by two factors: the limited size of available emotional speech data sets and the natural variability in how different speakers express it. This doesn't diminish the system. It points clearly to where future work should focus, compared to prior systems that's degraded under emotional speech. To summarize what we have set to do and what we have achieved, we proposed a voice-based security framework that combines MFCC-based speaker verification with a CNN LSTM emotion recognition, with a deliberate architectural choice to keep these two functions independent. We validated the systems on the Revert REST dataset, achieving approximately 93% voice authentication accuracy, 97% passphrase accuracy, and 61.45 emotion recognition accuracy. Our findings show that combining biometric security with emotional intelligence improves system reliability, not letting emotion control access, but by providing context that makes the system smarter and more securely reliable. This framework is practical, scalable foundation for secure voice interfaces in access, human-machine interaction, and AI. We're proud of this system demonstrates, and we are clear-eyed about what comes next. With this, the architecture we have built, here is the right foundation for all of these extensions. Thank you, and I'm happy to take questions. Okay. Even if two people have the same wavelength, it can verify easily because our vocal codes are different in each human being. It's as unique as a fingerprint. Even if two humans have the same voice, it still gets identified in the system because each human has its own vocal code and it's as unique as a fingerprint. So even if three people have the same voice, it will still identify. I chose that because it's fast and interruptedly, it doesn't need retraining from new users. That's why. Because our system requires a live microphone and recording, and it captures in real time. Second, the passphrase recordings checks at the second gate. And if someone plays a recording which she asked, that would also need to know the exact phrase, and we acknowledge that we do not have deepfake detection. So this explicitly is in our future work, we're working on it. Thank you. Anyone? Thank you. Okay. Thank you, sir.